So since this is the first session, so first I'm going to cover like the topics, the number of topics, and the list of topics that I'll be discussing with you. This is what we are going to cover now during next maybe a month. Let's go through that first, and then we can probably start with the topics and all that. So it will be like a kind of introductory lecture. That's what we are going to have today. So for F5 LTM, right? So basically, all of you are here for F5 LTM and GTM in, like most probably, as long as I am aware of. But the first topic that we are going to cover is F5 LTM. And once we are done with F5 LTM, then we will be going for F5 GTM, also known as F5 DNS, right? Domain name server. Because without covering LTM, if anybody starts with the DNS, which means GTM, then it becomes a little difficult for them to cover GTM directly if they don't have any knowledge around LTM, right? So it is always important for anyone to cover the LTM based training first and then go for the other modules of the F5, like maybe GTM or maybe APM or ASM, whatever.
This module will cover only LTM.
That's right. So first we will cover LTM and then we will start with the GTM.
Okay. But
So
is GTM part of this course?
GTM is not part of this course. Basically, it depends like what sort of training you have opted from I-MEDITA. So basically, they probably they have a course which contains only LTM, but also they have a course which contains F5 LTM and GTM both, right?
Okay, sir.
So now I don't know like in which course you got yourself enrolled, but the point is like ideally people get enrolled for LTM and DNS both, and first we cover LTM and then subsequent in subsequent manner we cover the GTM. Okay, so this is the F5 website, similar to like what we have for Cisco. So this website, this F5 website is very useful. Like obviously you can see what's going on within F5, and apart from that, you can also look at here that they have got multiple tabs there, and especially if you look at the resources, right? So under resources, they have the education tab there, right? You can see there. So they have got this education tab. Once you click there, it will give you like professional certification kind of tab, and just click there, right? So professional certification. So within F5, you have got different types of certifications that you could go for, right? So first exam that you must go for is 101. Remember, 101 is going to be prerequisite before you take on any other exam. So first you have to take on the 101. Once you are done with this 101, then only you can go for maybe 201 exam, right? So basically, the exam structure is quite similar to what Cisco has, but there is a slight difference. Like in Cisco, you can directly attempt like CCIE exam by covering the NCore. If you are looking for CCIE kind of enterprise infrastructure, then you just have to cover the enterprise core. That works as a written exam, and then thereafter you just have to attempt the lab examination, but you don't really have to complete your CCNA certification before attempting your CCIE exam. But here in F5, it's mandatory. You can directly jump on 401. You can directly jump on 301. That's not gonna be possible. Even F5 will not allow you to book your exam. So the first exam that you will always have to take on is 101 exam, which is application delivery fundamental. So that's where you learn about like what is the application delivery controller, right? ADC. So the load balancer is also known as the ADC, application delivery controller. So it's not that big terminology. It's just that we are calling our load balancer, the F5 LTM, as a ADC, application delivery controller, right? And apart from that, you just go through the OSI model, like which all are all different layers we have got within the OSI model, and then TCP/IP model, encapsulation, decapsulation, right? The TCP three-way handshake, the functionality of HTTP, functionality of FTP. So all sort of basic things you will have to cover during this 101. Right. So I would suggest each one of you, like all of you, right? Whoever is on call as of now, I would recommend each one of you, please go through the TCP/IP model, right? No matter which book you are referring, but refer any one book, right? And then just go through that. It is really important for each one of you to cover the TCP/IP model or OSI model. Just see that how TCP is performing, and that is very important. Especially, monitoring TCP is very important because whenever you deploy any application on your application delivery controller, and just in case if it is not working, if application is not behaving as expected, then it becomes really important for you to perform the troubleshooting on your on your load balancer. And you will have to prove yourself that yes, it is not a problem from the load balancer. So at that level you must be performing troubleshooting on your load balancers, right? So I mean, this TCP/IP model is going to be very, very important and critical thing here, right? So when I say OSI model, which means like I'm talking about the TCP, UDP functionality, IP functionality, because IP encapsulation is also happening at layer 3. And at same time, TCP is there performing three-way handshake, but that's not the only function of TCP. Not only it performs three-way handshake, but also it finishes up the connection. Sometimes you get the resets, right? Sometimes you will be getting duplicate acts, dupacks, right? Sometimes you will be getting the duplicate segments itself. So you have to be aware of all the possibilities that could happen in TCP, right? And then obviously the impact on TCP connection, just in case if something is suspicious. Because if you know that if you get reset, then you have to reset your connection will get resetted. If there is too much retransmission, then also your retransmission is happening, then again the connection might get reset. So there are various reasons, right, due to which your TCP connection could reset it. So point is that this 101 is all about the fundamentals, whether it is OSI model. In fact, if you talk about the network layer, right, IP addressing, IP subnetting, then at data link layer, you have got MAC addresses, how things are happening, Ethernet header. So that's all part of this application delivery fundamentals. Apart from that, then they get started with big IP, right? Like what is big IP, and then how many different types of big IPs you get, like cloud version, virtual edition, and then the hardware devices, right? And then capabilities of those big IPs, and then different modules, and then different types of load balancing that LTM supports, right? So like basics of big IP is also there, right? It's not about just TCP IP model, right? It has got the basics of the ADC as well, the fundamentals of ADC, right? Application delivery controller. So, and then you can attempt, like if you are aware with all those sort of things, then you can simply attempt this exam. You can also look at the study material, which can, like if you browse to the study material, then thereafter you can simply go ahead and you can look at the topics of the list of topics, right? So you can simply look at the topics of this exam 101, right? And then you can prepare yourself accordingly, right? So that's 101. After 101, then you get like two options. Either you can go for 201 or maybe 202 or maybe both of them. So 202 is for the sales people, right? Like who are working in pre-sales. It's mandatory for them. Like if you are working for F5 in the pre-sales team, then it is mandatory for you to pass this exam. But yeah, I mean, ideally for technical people like us, right? So we can simply go for 201. Now 201 is all about the big IP administration. Now, what is big IP administration, and what is the difference between big IP administration and the LTM based training, right? So let me tell you, big IP is a box, right? Big IP is a box that facilitates you to deploy different types of modules if you wish, such as LTM, GTM, APM, ASM. Those are the different modules which we could activate on the big IP. But big IP is going to be common whether you are utilizing it as a LTM, you are utilizing it as DNS, or you are utilizing it as ASM, APM, whatever module you are activating, but big IP is going to be common. And that's a cool thing that I see here in F5, because see, if you take an example of Cisco, right? So in Cisco, the box for ASA is different, the box for FTD is different, the box for router is different, the box for switch is different, right? I mean, you don't get the kind of like common box which could be utilized as we wish to use it, right? Um, so it's, I mean, even not only in Cisco, but even if you look at any other vendor, right? So it's difficult to find a box or find a hardware that could be leveraged or that could work as different, that could work differently in different scenarios, right, with different requirements. But big IP is like that, right? So we have got a common big IP. Big IP is a box actually, that runs an operating system which is called TMOS. traffic management operating system, which is built on top of the Linux. So kernel is Linux, and TMOS is the operating system here on Big IP, right? So traffic management operating system, that's what you installed on your Big IPs. Ideally, you would have two different types of Big IPs. One, the virtual one. Second is hardware one, right? I'll also come to that point as well. Point is that operating system is common, and then how Big IP boots up, how you allocate the IPs to Big IP on its interfaces, how you create VLANs, how you configure interfaces, right? How you take the backup of the Big IP, how you restore the backup of the Big IP, configuring Big IPs in high availability mode, and then configuring admin authentication on Big IP, integrating with syslog server, integrating with SNMP server, with NMS, then integrating with TACX for admin authentication again, right? Or maybe with Active Directory for admin authentication. And then enable routing, whether it is static routing, dynamic routing, then configuring ether channel. So that's these all sort of things are part of the Big IP. These all things are part of the TMOS administration, because you are trying to manage your Big IP. So here you just work on TMOS. You're not working specific to a module. Like, you're not learning LTM, like how LTM is working, how it is performing load balancing, how you are deploying the application in LTM, how you are deploying applications in APM, and then how you are deploying or how you are securing your application in ASM, right? You don't learn that. You don't learn that how to work on GTM. First, you learn that how to work on this Big IP as a box, because it is important for you to understand that how we configure various things on this box. And remember that the configuration of the Big IP is going to be common across all the modules, whether you are working on LTM, ASM, APM, GTM, no matter that which module you are working on. But the Big IP configuration is going to be same. The upgradation of Big IP is going to be same. Downgrade, like if you wanted to downgrade the Big IP, is going to be same. Installing license is also going to be same. So Big IP is common for all modules. So we have got a common box and common operating system. So that's a cool thing. Like in Cisco, what you get is, like, for switches, you get a different operating system. For firewalls, you get a different operating system. Or maybe for firewalls and routers, you get different operating systems and different command syntaxes. Even within switches, they have got like Nexus switches, and then the switches running IOS XE, and then they have got the different command syntax once again. So those complexities are not here in F5. We have got Big IP, and Big IP is going to be common, no matter which type of module you are looking to activate. So that's a good thing for us. So overall, you would be learning that how to work on Big IPs, how to work around the TMOS operating system. Like, that how to work on Windows, right? That way you just have to learn that how to work on TMOS, like the basics of the TMOS, not basics, I would say. Like, you would learn that how to administer your Big IP, because Big IP is a box. It could be hardware, it could be virtual edition as well. So that's what you learn under this certified administrator. And once you complete your 201 exam, let's say you have done 201 exam, you attempted 201 and you passed it, then you become like certified administrator. So post completing 101 and 201 both, you will become now CA certified administrator, which is equals to CCNA in Cisco. And then after, you can see that you have got like CCNP type of certification, which is also known as CTS, certified technical specialist. And you can become CTS post attempting your either, like, even if you become, like, if you pass 301A and 301B, remember that for LTM, we have got like two separate exams here for LTM. And these two exams, 301A and 301B, is specific to LTM only. Okay. So if you want to take on the LTM examination, then you have to attempt for 301A and 301B. 301A is all about the technology, and 301B is all about the troubleshooting. So like, they have segregated these two exams from each other, right? The troubleshooting is different, and then deployment is different. So 301B is all about the maintaining the F5 Big IP LTM, right? And 301A is all about the deployment of the LTM. So that's a difference. Once you complete 301A and B both, then you become CTS in LTM. You are CTS now, but in LTM only. And then you can also attempt like DNS exam over there. You can also attempt the ASM exam. You can also attempt the APM. Now ASM is now renamed by F5. It's not ASM anymore. It's like WAF or advanced WAF. So F5 calls it advanced WAF, right? Web application firewall. That's what ASM is. The APM is a remote access solution kind of thing, right? So that's access policy manager. So access policy manager, like if you are looking for access policy manager exam, you can also attempt that. Now there is some expert level, like solution expert, certified solution expert, CSE, which means that expert level certification is also there, right? So for example, if you want to attempt your certified solution expert in security only, then there are prerequisites. The prerequisite would be that you must have 301A, B, both 303 and 304. Remember, right? So these all four exams you must complete before you take on the 401. Similarly, if you want to take on the 402, then it is mandatory for you to obtain the LTM and DNS both examination. Then you can go for 402 cloud, right? Before that, you cannot even book 402 cloud. You can't. So you have to go through the process. You have to go step by step, right? You can't bypass any of the certification. Okay, so this is how the certification is designed in F5, right? And now the next thing is that you can also go back here and then you could look for the probably products, and then under products you get like multiple things there, right? F5 NGINX, F5 BIG-IP, F5 systems, right? So this is what we are covering here, right, in our training. F5 BIG-IP. So if you click on F5 BIG-IP, then within BIG-IP you get like multiple options there, right? You get like BIG-IP, DNS, then BIG-IP, APM. These all are the different modules, but BIG-IP is common, right? BIG-IP. Now, the meaning of the BIG-IP, don't think of like, okay, it has some bigger IP address, it's not using IPv4 or IPv6. No, don't think in that way. BIG-IP, they have named their box, right? So F5 named their box as a BIG-IP. So they have got like cloud edition. They have also got the like virtual edition. You can see that like this virtual edition. Now they have came up with BIG-IP Next as well, right? So they are also using next gen BIG-IP software that simplify operations, increasing security boost. So we are not going to use BIG-IP Next as of today for our training. We will be using BIG-IP, normal BIG-IP, right? Not BIG-IP Next. But they have already launched this BIG-IP Next, and it was launched recently by F5, right? So within BIG-IP, you can see that we have got BIG-IP Virtual Edition, and also we have got like the BIG-IP. Like if I go to F5 systems, right? That's where you would get to know that okay, they have R series of appliances, they have got I series of appliances, they have got Velos chassis, they have got Vaprion chassis. I mean, if you look at the right side, right? So if you look at the right side, like Velos, chassis, and blades, right? So that's a chassis, and then also we have got like Vaprion chassis and blades, right? So these both are chassis. Those are giant load balancers, giant BIG-IPs, right? Big IP. Those are chassis. And in left side, you see that R series is there. These all are appliances, like R series appliance is there, then I series appliance is there. Remember, this R series is that kind of appliance or that kind of hardware that supports the virtualization. This R series is built in such a way that, let's say, I mean, again, it will be depending upon different models that how many BIG-IP you can install on this R series of appliance. But they have got models in R series appliances, like you can install like up to maybe 4 BIG-IPs there, the virtual BIG-IPs, the 4 different virtual BIG-IPs. You can allocate dedicated CPU cores, memory, the number, the interfaces. So you get so many interfaces available on this R series of appliance, and then you can use them. You can allocate the interfaces, CPU cores, and memory for different virtual BIG-IPs. So you install like virtual BIG-IPs on top of R series appliances. So it supports virtualization. It's like F5 is just trying, to avoid like using sort of third-party hypervisors and third-party servers. Like we ideally use ESXi servers, and on top of ESXi servers, sometimes we install the virtual BIG-IP. So now F5 is suggesting their customers that rather than using, like maybe IBM server or Dell server, and then on top of that, then you are using ESXi, and then you are installing BIG-IP, virtual BIG-IP there. So it becomes very difficult to perform troubleshooting, because you have to get each and every stakeholder on the call. Like from hardware, from the hypervisor, and then from F5 as well. And then collectively, you would start performing load troubleshooting just in case if something is not working. So what F5 has done, they have launched this R series of appliances, and that R series of appliances allows customers to deploy the big IPs virtually, right? So like now how many big IPs you can deploy on one single appliance, that depends like which model you have purchased from F5. So like they have got different models under R series of appliances. Like if you go inside the R series of appliances, it's pretty cool. And this appliance comes with F5 OS. So there is an operating system called F5 OS. So that is pre-installed on this on these R series of appliances. And then once you boot up your big I big IP R series of appliance, let's say you have booted up, then it will boot up with F5 OS, and then you would have the GUI access of it, and then you can simply deploy. Now you can look at here, right? So you can simply deploy the virtual big IPs then on top of that using ISO images. So you will be using ISO images to install the big IP on. I mean, you can have multiple big IPs actually, right? So
Saurabh, sorry to interrupt. This R series are based on that VCMP, right? VCMP.
is kind of that, yes, kind of that, but they don't really call it VCMP here, right? It's like multi-tenancy 36 tenant. This is what they call it, right? But yes, you are right. It's like in Viprion, we call it VCMP.
Yeah, Vipron, right? Vipron.
Yeah. So this R10,000 series
So
of box, like, yes,
Vipron having a different hardware,
architecture. Yes, that's a
different.
different architecture and
Okay, and
different
these
hardware.
R series are different. Okay,
It's different. It's an appliance. If you look at here, right? It's an appliance here.
okay, and Vipron is the hypervisor, correct? Similar
Viprion is
to
chassis based device. Chassis.
chassis
Like it's
based.
a box, and then that has got multiple slots that you can install there, right? So that gives you add-on feature, right? As compared to this R series, because R series is an appliance, you can't have like multiple slots available. Like if you talk about the Viprion or Veloz, the
Mm-hmm.
advantage you get there, like you can have multiple slots, and there are multiple
Chassis.
slots available in that chassis, and then you can have multiple modules installed, the hardware modules. And then when you deploy a big IP, you can allocate resources from different blades. So just in case if the entire blade fails, let's say in
Mm-hmm.
Viprion or maybe in the Velos, right?
Velo.
Still your big IP will keep on working, because that has got some resources from other blade, and that is working perfectly fine. So that's kind of like you get the redundancy at hardware level as well, but you don't get that feature over here, right, in R series.
Okay.
So R series, like if you look at for a large enterprise and service provider, they have came up with this model R10,000, and this is what it supports. Like most importantly, it supports 36 tenants. Now R5000, that supports like 18 tenants, right? And also it should have like small to medium. I worked on 4000 series, R4000 series, and it supports like 4 tenants. So you can see here that it is supporting multi-tenancy, and there can be 4 tenants. So when I say tenants, which means that 4 different big IPs can be installed, 4 different big IP, and each big IP can work differently. Like one big IP you're utilizing as maybe LTM, the other big IP you're utilizing as DNS or so and so. That's that. And then 2000 is also there, but this like, why are we using R series then? Why are we using R series? Yes, Muskan, go ahead.
Sir, LTM big IP got the chases, and it's our choice. We can use it whether LTM or a
Correct.
GTM.
So big IP is a box, right? It's a
Okay,
box. It can be hardware, it can be virtual.
okay. And you told like the Viprion chases, we got multiple modules. So each module will work as a different LTM for different applications or whatever
No,
services
no,
we have.
no, no, no. So here, these all are the appliances, the R series
Okay.
and I series. So I believe that first we have to understand the difference between chassis and the appliance. So, I
Okay.
mean, are you aware that the differences between appliance and the chassis, those
Mm,
terminologies? So appliance
no.
is like single device, right?
Mm-hmm.
You don't get slots to
Okay.
add the blades and all that kind of things, right? Those are
Mm-hmm.
fixed boxes.
Okay.
Right? You can install the SFPs, that is okay, right?
Mhm.
You can install SFPs and you can make the connections. So that's what you would get for appliances. But appliances are fixed boxes. Okay. But chassis is different, right? Chassis is like a big box. It's like in Cisco, 4507, 450, 4510. Those are chassis based switches, right? But then at
Yes.
same time, you get 3800 series or 3700 series or maybe 9300 series. So
Yes.
those are the appliances, correct?
Okay.
Because that has got like fixed architecture. There are no
Right.
slots. I mean, slots are there, but just to install the SFPs. But
But
you
you
can't
can
you can't install the entire module there, right? That's
right,
not
right.
possible on that. So those are the appliances here in left side,
Okay.
right? And at right side you have got the chassis like the Velos and Viprion, right? Those are the chassis. Viprion are the older one. Velos are the latest chassis that F5 has launched. Earlier we
Okay.
had only Viprion. Now, when you talk about the Viprion chassis, let's assume that. So Viprion chassis and blades, let's Google it and let's look at the images. So if you look at the images now, look at there. So it's like, wow, right? F5 network, Viprion chassis. So how many slots you see there? There are four,
Four slots.
right? And there are four modules installed there, right? The four blades, basically, I would say, right? There are four blades, right? So this is chassis, right?
So do they have the soup concept or something like that as well?
No, because it's not a switch, right?
Okay.
It is not a switch. So they don't have like line card. Soup is there. Obviously, without CPU, you can't do right anything. But
Right.
each blade has got its own resources. Each blade, right? So like
Okay.
there are four blades. Then each blade would have like number of CPU cores, the memory, the storage, the number of interfaces, right? And when you create the VCMP guest, like there will be a host and guest, right? So when you create a guest, like you are installing now, because on top of it, like you will be installing the big IPs now virtually. So when you install the virtual big IP on this chassis, then you can allocate like there are four CPU core from Blade 1, and then another four CPU cores are allocated from Blade 2. You get my point? Now, in case if one of the blade goes completely down, still your big IP is running. Why? Because it has got resources from the other blade.
Okay. So, sir, the two blades will be active standby concept, you mean?
No, both blades will be working in active mode.
Okay.
So sort of how it allocates the resources in this, like disk and memory,
You have to allocate that.
we have to manually allocate.
Yes, when you deploy the big IP, you get the option that okay, how many CPU core you want,
Okay.
how much of memory you want, and from which I would say blades, because there are multiple blades. So it will also ask you that okay, from which blade you want to allocate the resources. So that's how it works basically. But remember, in this training, we don't have a prion here. You would not get that chance. But it's just that I
Yeah.
am explaining that how does this behave. So this is how it looks like. So we have got like 2400, 22, 2400 series of chassis as well, where you get only two blades like this, just two blades. And then there is a 4400 series of chassis as well, where you get like four blades. So also like within Viprion, you have got like different types of chassis.
सर ये ब्लेड कॉन्सेप्ट नहीं समझ आ रहा.
अच्छा, ब्लेड कॉन्सेप्ट समझ नहीं आ रहा है.
हम यूज किस लिए करें मेरे को. आई एम गेटिंग डाउट देयर कि
अच्छा,
ये
सिस्को में ये
हमारे पास
बताइए
चार
मेरे को,
ब्लेड
4507 आपको याद है? थोड़ा सुपरवाइजर एंड लाइन
हाँ
कार्ड वैसा याद है? ये
उन पे
ब्लेड
हमारे
वही है. ये ब्लेड
ओके
वही है, बस वहां पे क्या था कि यू हैड लाइक डिफरेंट लाइन कार्ड्स एंड डिफरेंट सूप कार्ड, राइट?
हाँ जी
But यहाँ, like here in F5, we are not using this F5 load balancer as a switch, right? We are not using it as a switch, so we don't need that much port density here. We don't need
ओके
that much port density. और वही आप देखोगे यहाँ पे कितने पोर्ट्स हैं यहाँ पे, ये मैक्सिमम आपको 22 के अराउंड पोर्ट्स देखने को मिलेंगे. तो जो एडवांटेज मिलेगा ना आपको यहाँ पे वो ये है कि आप जब बिग आईपी डिप्लॉय करते हैं तो आइडियली आप कैसे डिप्लॉय करते हैं? तो आपको हायर परफॉर्मेंस चाहिए, दैट्स वन थिंग. एंड साथ में आपको क्या चाहिए? रिडंडेंसी चाहिए, कि अगर एक ब्लेड पूरा फेल भी हो जाए तो आई स्टिल वांट कि माय बिग आईपीज आर स्टिल वर्किंग एज इट इज, लाइक द बिग आईपीज आर हेल्दी. आई वांट टू डिप्लॉय देम इन दैट वे। तो
Okay.
उसमें हम क्या करते हैं, जैसे मान लीजिए एक बिग आईपी डिप्लॉय करना है मुझे, तो उसको रिसोर्सेज तो देने होंगे ना, लाइक नंबर ऑफ सीपीयू कोर, मेमोरी एंड सो
Mm-hmm.
इंक्लूडिंग स्टोरेज। तो हम क्या करते हैं, वो दो अलग अलग ब्लेड से रिसोर्सेज एलोकेट कर देते हैं। वो ऑप्शन मिलेगा आपको जब आप डिप्लॉय करते हैं ना, तो वो पूछता है कि कितना
Okay.
मेमोरी देना है, कितना सीपीयू कोर। तो आप दो अलग अलग ब्लेड से सीपीयू कोर और दो अलग अलग ब्लेड से ही मेमोरी पिक कर लेते हो। जैसे आइडियली यू नो दैट for your big IP you are thinking of like, okay, maybe 8 cores are sufficient
Mm-hmm.
and 16 GB of memory is sufficient, right? तो आप क्या करेंगे, 8 core from each blade, 16 GB of memory from each blade, तो ओवरऑल वो 32 हो जाएगा। एंड उसके अलावा आप क्या करेंगे यहाँ पे कि जो इंटरफेसेस लेंगे ना, वो भी दो अलग अलग ब्लेड से ले लेंगे। सो जस्ट इन केस इफ वन ऑफ द ब्लेड completely goes down, your big IP, the virtual big IP that is installed on top of this VPN, that is still has everything that you know that will keep running that virtual big IP. Make sense?
Okay.
तो वैसे है ये कि जैसे सूप सूप कार्ड में आपका एक एक्टिव एक स्टैंड बाय रहता है, यहाँ ऐसा नहीं है, दोनों एक्टिवली काम करेंगे एट सेम टाइम, बिकॉज व्हेन वी आर इंस्टॉलिंग द बिग आईपी, वी आर एलोकेटिंग रिसोर्सेज फ्रॉम बोथ ऑफ द ब्लेड्स। तो
Okay.
अगर एक ब्लेड कंप्लीटली डाउन भी जाएगा तो भी दूसरे ब्लेड के रिसोर्सेज हैं उसके पास, और दूसरा ब्लेड एक्टिव है, तो चलता रहेगा बिग आईपी आपका, इट्स नॉट गोइंग डाउन। तो ये एक बड़ा एडवांटेज आपको मिल जाता है बाय लेवरेजिंग, बाय यूजिंग दिस चेसी। अब
Okay.
ऐसे ही आपका, अब अगर आप अप्लायंसेस की
Uh,
बात करोगे।
Sora, but what one VCP guest is equivalent to one
करेक्ट, यस एब्सोल्युटली,
one unit, right? One
यस,
F5
यस, वन बिग आईपी, नॉट F5, विल
or
कॉल
one
इट
big
बिग
IP. Yeah.
आईपी। दिस इज हाउ द आर सीरीज लुक्स लाइक, राइट? ये आर सीरीज का एक इमेज है यहाँ पे, ये देखिए, ये दिस इज अप्लायंस, राइट? अब यहाँ कोई चेसी नहीं है, मुस्कान, राइट? आर यू एबल टू सी इट? ये देखिए, ये इसको अप्लायंस बोलते हैं हम।
Okay.
ये अप्लायंस है। सो दैट्स अ मेजर डिफरेंस बिटवीन अप्लायंस एंड चेसी। चेसी यू विल ऑलवेज हैव लाइक मल्टीपल स्लॉट्स, वहां ब्लेड इंस्टॉल करते हैं। अब यहाँ ब्लेड इंस्टॉल नहीं कर सकते, ये तो फिक्स्ड है ना,
Hmm.
राइट?
Yes, sir.
ये फिक्स्ड है डब्बा। तो ये चेसी और अप्लायंस में ये मेजर डिफरेंस होता है। बाकी पोर्ट्स हैं, यहाँ पे काफी पोर्ट्स हैं, आप देख सकते हैं एसएफपी बेस्ड पोर्ट्स हैं, आपको एसएफपी इंस्टॉल करना ही पड़ेगा, विदाउट एसएफपी तो आप यूज ही नहीं कर सकते, राइट? RJ45 वाले जो पोर्ट्स हैं वो नहीं दिए हुए हैं यहाँ पे, एक्सेप्ट कंसोल एंड देयर मैनेजमेंट। इनफैक्ट आर सीरीज में तो आई बिलीव मैनेजमेंट पे भी आपको एसएफपी इंस्टॉल करना पड़ता है, इफ आई एम नॉट रॉन्ग। यहाँ पे देखोगे लेफ्ट साइड वाला शायद ये एसएफपी ही रहेगा। सो दैट्स अ होल पॉइंट। तो इस तरीके से आप इसको देखते हो, बहुत एडजेसेंट पोर्ट मस्ट बी 40 गिग एंड 100 गिग, नो मिक्स एंड मैच। तो ये 40 गिग 100 गिग वाले पोर्ट्स भी अवेलेबल हैं तो ये चीजें हैं, दैट्स आर सीरीज। ऐसे ही आप आई सीरीज को भी सर्च कर सकते हो यहाँ पे, जैसे आई सीरीज अप्लायंसेस में जाएंगे आप, तो वो भी आपको दिखाई दे जाएगा। अच्छा, आई सीरीज डज नॉट सपोर्ट वर्चुअलाइजेशन, ओके? इस पे डायरेक्टली टीमोस इंस्टॉल होता है, इसमें कोई हाइपरवाइजर टाइप ऑफ कॉन्सेप्ट नहीं होता है यहाँ पे। ये जो टीमोस होता है ना आपका, ट्रैफिक मैनेजमेंट ऑपरेटिंग सिस्टम, दैट डायरेक्टली गेट्स इंस्टॉल्ड ऑन योर आई सीरीज LTM, आई सीरीज बिग आईपी, सॉरी, आई सीरीज ऑफ बिग आईपीज, राइट? तो इसमें क्या होता है, टीमोस डायरेक्टली इंस्टॉल होगा, कुछ ऐसे अलग अलग बॉक्सेस आते हैं, राइट? कुछ 2RU वाले होते हैं, कुछ 1RU वाले होते हैं, बट दे डोंट सपोर्ट वर्चुअलाइजेशन। जैसे यहाँ पे हमने देखा आर सीरीज में, लाइक वी कुड इंस्टॉल मल्टीपल टेनेंट्स, टेनेंट मतलब टेनेंट इज इक्वल टू बिग आईपी, वर्चुअल बिग आईपी। बट आई सीरीज में ऐसा नहीं होता। सो इफ यू लुक एट आई सीरीज ऑफ बिग आईपीज, तो दोज आर दी बॉक्सेस जिसपे डायरेक्टली टीमोस चल रहा होता है। तो अगर आप देखोगे यहाँ पे, लाइक लुक एट हियर, 15,000 सीरीज, जो कि आइडियली सर्विस प्रोवाइडर्स के लिए बना है। 2RU वाला है ये, 2 रैक यूनिट, मतलब थोड़ा बड़ा होगा ये, चौड़ा मतलब थोड़ा थिकनेस ज्यादा होगी उसकी। और 11,000 सीरीज वो 1RU में है। दोनों में डिफरेंस क्या है? बट दोनों में से कोई भी आप देखोगे यहाँ पे, नोबडी इज सपोर्टिंग टेनेंट्स या वर्चुअलाइजेशन, कुछ नहीं है। क्यों? क्योंकि टीमोस डायरेक्टली गेट्स इंस्टॉल ऑन दीज बॉक्सेस। कोई यहाँ पे आपका वैसा नहीं होता कि एक टाइप, जैसे मैंने बताया ना, आर सीरीज में क्या होता है, F5 OS। आर सीरीज में F5 OS होता है, और F5 OS के ऊपर देन यू डिप्लॉय द बिग आईपीज, राइट? तो F5 OS इज वर्किंग लाइक हाइपरवाइजर, but that concept we don't have for this I series of appliances। आई सीरीज के अप्लायंसेस में इस डब्बे के ऊपर ही ऐसे मान के चलो, जैसे आप लैपटॉप लेकर के आओ, लैपटॉप में डायरेक्टली क्या इंस्टॉल कर दिया, विंडोज। बायोस तो रहेगा ही, वो यहाँ पे भी रहेगा होस्ट वगैरह परफॉर्म करने के लिए। बूट स्ट्रैप तो यहाँ पे भी रहेगा ही ना, ऑब्वियसली वो हर एक डिवाइस पे होता ही है, डिवाइस को अप करने के लिए। बाकी अगर आप यहाँ बात करोगे तो ये ऐसे ही है जैसे लैपटॉप में आप विंडोज इंस्टॉल कर रहे हैं, ऐसे ही टीमोस जो ऑपरेटिंग सिस्टम होता है बिग आईपी का, सो द टीमोस ऑपरेटिंग सिस्टम, traffic management operating system will directly install on top of these boxes, I series of boxes. So you are directly installing the TMOS on these boxes. And then you can look at the capabilities of these boxes. Ideally, you would work on 10,000 series or 7,000 series in most cases. So you can see that what are the capabilities of the 10,000 series of big IP and then 7,000 series of big IP. So layer 7 request per second, 3.5 million, right? And layer 4 connections per second, L4 HTTP request per second, maximum L4 concurrent connections, and then throughput 160 Gbps. That's the overall throughput of this box. So you can look at simply its capability over here, right? But remember, it does not support any virtualization, and then TMOS directly gets installed on top of this appliance, right? I series of appliance. So it doesn't support the virtualization. Then if you wanted to look at, like for an example, once again F5 systems, and then for chassis you have got like two different options like Velos and Vaprion. So Velos is the latest series of chassis. It's the latest chassis, and now F5 is like pushing their customer to either use the Velos chassis if they want to use chassis and blades, and if they are looking to use the appliances, then they are pushing customers to use the R series of appliances. So the current focus of F5 is to sell R series of appliances and Velos chassis to their customers, because at one point, at one stage, the Vaprion will become end of sale. I series will also become the end of sale, and then at one stage it will also become the end of support from the F5, the Vaprion chassis as well as the I series of appliances. So going forward, you would see that you would be working only on the R series of appliances and Velos chassis and blades. If you look at the Velos chassis and blades, this is how it is gonna look like. I'll show you the pictures. It's quite similar to what you had in Vaprion. So it's like Vaprion chassis. You see that now, right? So this is Big IP Velos chassis. So you can see that it's quite similar to what we had for the Vaprion. So you will be installing blades. You would have like slots available, and then you would be installing blades on your F5 Velos chassis. When you talk about from a product line, then Velos chassis and Vaprion is kind of like from a similar category, right? Both are chassis. So if you look at the Velos now, they have got like different chassis. CX410, that's a chassis system, right? And then they have got only one blade, which is BX110, right? So this is the blade that you can install there. So chassis is the next generation chassis, right? And then they have got just one blade there. So CX410 chassis, and then simply if you look at, and also you can look at the data sheets, right? So that would give you more information about that. So if you look at the data sheet here, if you look at the architecture, and then it will give you like more information about the chassis. This is chassis, right? And this is your blade over here, right? BX110. And it should also give you like, okay, what's throughput, the number of SSL connection, right? So that was the chassis. And then if you keep rolling down somewhere, you would see that, okay, these are the capabilities of, yeah, you have got that now.
सर
So
यहाँ पे ब्लेड मॉड्यूल है क्या?
yes, yes,
Okay.
yes. So it's like terminology, right? In Cisco, we call it module, right? Like the line card and soup card, those are the modules, right? But here we call them blade.
Okay.
Yeah. And then also if you keep rolling down, it is also showing you that how many CPU cores it has got. It's just one blade, right? So one blade has got that many CPU cores, the memory, right? And then also you can look at the other information like hard drive capacity, number of network interfaces, and then traffic processing. That's more important, right? So that's what you would see. So one blade will support that much of capability, right? So, and again, like you will be installing virtual big IPs on top of the chassis, and then you can use those big IPs for different purposes. Like one big IP can be used for LTM, the other can be used for DNS, right? These all are the different modules, right? That F5 supports. like AFM, WAF, advanced WAF. Earlier, that used to be known as ASM, right? But now, for examination, they are still using the same terminology ASM, right, for examination. But ideally, they have renamed their product now, their product from ASM to advanced WAF, right? Some people call it a WAF, right? So don't get confused. It's same thing. So that's that. So you can always look for all these hardware information, right? You can Google, or maybe you can simply look at the videos that people have put on the YouTube for all these hardware. But we do not have the hardware for the lab. We will be using the virtual edition here to perform all our labs. So for LTM, let me show you the topology that we will be using during our training quickly. Let me connect myself with the lab, and then I'll display you the topology that we are going to use.
Sir, and this what we heard is like nowadays they are doing container base. So these are all product support that container base services.
Yes, that's why like they are having these cloud ready devices, right? Like our series of appliances, and they have also launched uh, the Veloz chassis, right? So those are the cloud ready, right?
Okay.
Yeah. Okay. Now I'll just open up the topology. So if you look at the topology that we are going to use for the F5 LTM would be, come on. Mm, That's the topology that we will be using here for the LTM training. So you can see that in this topology we have got like a set of big IPs that we will be setting up in HA, high availability mode, and then in backend we have got like various servers, right? So you can see that there is a server 1, 2, 3, 4, 5, 6, right? And then we have got the user sitting behind the internet, right? So behind internet we have got the user, and then we have got the data center. So it's an ideal, topology that ideally we use even in production. Although in production you would have like multiple connections, or there may be inclusion of the firewall. I mean, there will be, obviously, not maybe, there will be inclusion of the firewalls as well in the topology or in the transit. But we can't keep like everything. I can't really replicate the actual data center here in our topology, because the objective is to learn the functionality of the big IP, and that's what we have got here, right? So we do not have any firewall there, right? But obviously in production, you would see that in transit, the firewalls will always be there, right? Because without firewalls, you cannot expect any network to work, right? Do you agree with that statement?
Yes, sir.
Yes, sir.
Yeah. So this is the topology. And then at down left side, right, you would see that there is an internet user. And that user will come through the internet and will be accessing the applications that you would be hosting in your data center via your load balancer. So we will be learning that how to host those applications, right? Such as your, for example, if you have got the SFTP, or maybe you have got the web application. Mostly you would always have the web applications that you would be hosting in backend. So ideally, like I've worked on F5 technology for a long time, right? And I have seen that I mean, in most cases, we are using the web application. So our focus will be on web application, but it's just not web application. You can also deploy like some sort of SFTP or maybe FTP, right? And also you can deploy the other applications as well. There are many examples, many applications that you could deploy. Like even sometimes people deploy the Cisco ICE behind the load balancers, their PSNs, especially like policy server node, not admin node, but the policy server nodes. So PSNs will be deployed behind the F5 load balancers, and the biggest advantage then you get is that you need to upgrade the PSN. You can easily upgrade them. You needed to remove the PSN. You can easily remove that, because you're not touching your switches, routers to update the PSN IP address. Because ideally, the biggest challenge, like with ICE, now I'm taking an example of the identity service engine here, right? I mean, in short, I would say I'm taking an example of the radius server. So whenever you deploy the radius server, you always have to provide those IP addresses to your switches and routers, right? Mainly switches, right? So that your end users can get authenticated from the radius server. The problem we get there is, like, if we are planning to upgrade the radius server, then obviously or maybe we are simply trying to replace the radius servers, then probably we might have to change the IP address, and that would that would really create a big challenge for us. Why? Because we might have to go to each and every device, and we might have to update the IP addresses. And if you are using radius server, you are installing radius server behind the big IP, then that eliminates that requirement of going, maybe if you change the IP address of the radius server, then you don't really have to go to each and every switch and change that IP address there, right? You don't have to update the switches. Why? Because your radius servers are sitting behind the load balancer. And load balancer will allow all your switches to talk to your radius servers using a single IP. And that single IP would be virtual server on your big IP. And in backend, if you are changing any radius server, let's say you are upgrading them, you are replacing them, or you are changing their IP address, that would not affect the connectivity. That will not affect the configuration of the switches in your environment. So that's kind of advantage you get if you are placing your radius servers behind F5 load balancer. So you would see not in every environment, not in each environment. I hope that each one of you have understood this now, right? That this is what we are going to use, right? So this is how we're going to have the big IPs in place. You would have the access to the same lab, right? And then you will have to set up these ISP routers and DC routers as well. Now, trust me, if you don't understand the routing, right? If you don't understand firewalls, it is very difficult for you to work on the load balancers as well. You can work. I'm not saying that you can't work. You can work, but at the time of troubleshooting, people might want to, they might they might make fool of you, right? Like in front of everyone, that okay, they are sending the traffic, they are not doing anything, or they are allowing the traffic. But you should be capable of saying that, okay, can you log into your firewall, show me if your traffic, you are passing the traffic, right? So if you are aware with that technology, it becomes easier for you to track them down and to ask them that what to check, right? Because sometimes, like while performing troubleshooting, there will be a guy from firewall team, there will be a guy from routing team, switching team, right? And then I'll be from like one engineer from the F5 side, right? Then there will be a collaborative effort. But over the troubleshooting call, when there is a call like that, everyone tries to say that, okay, no, it's not my device, it's not stopping anything, right? It's working perfectly fine, I'm passing my traffic, I'm allowing traffic. And then finally traffic, okay, the traffic, let's say, came through the big IP, it went back, but then still connection is not coming up, right? So obviously somewhere it is getting dropped. Maybe a big IP is doing something. Maybe big IP is dropping it. Maybe firewall is dropping it. Maybe there is a routing issue. Maybe there was asymmetric routing, and that's the reason that firewall is dropping that. So there could be various reasons, right? So I mean, if you're working on F5, do not think that you're not supposed to have knowledge on routers or maybe firewalls or switches. Like it is always good to have those ideas as well. It is always good to have that kind of knowledge as well, so that it becomes easier for you to work on the F5 load balancers and even to lead the troubleshooting calls. Okay. So this is the topology. The next thing that I would discuss now is the number of topics that we are going to cover during this training, right? That I'll discuss now. When it comes to the number of topics that we are going to cover during this training, let me just pull up something here. Give me a sec. Okay, yeah. This is the course outline that we are going to follow, right? So we're gonna start with the installation of the big IP. So that's where this is where we're gonna start with, right? So we're gonna start with the installation. Then we're gonna start with the load balancer, right? And then health monitors, the profiles, that would contain your persistence, processing, SSL traffic, NAT, SNAT, I rules are there, the high availability is there. So, and then you have got like some other stuff as well, like command line, the administration of the big IP, the profiles again, right? Part 2, where we covers like advanced profile, but I'll keep it simple, right? If I'm starting with profile, then I will get them covered at same time, right? Then IApps you have got there. virtual servers discussion, SNATs, monitoring, like all these things are there. So that's the content that we are going to cover during this training, right? If anybody has got any questions around the content that we are going to cover going forward, please go ahead and ask your questions. Now, what I expect from you, from each one of you, I expect from each one of you that you understand that how TCP connection is working. I expect that each one of you is aware with IP routing. I expect each one of you is comfortable with IP subnetting. Each one of you comfortable with VLAN. Like basically, I'm trying to say here that you are good with routing switching, right? And basics of the networking. So when I say basics, the fundamentals, right, which means the TCP IP model. So I'm expecting that from you, right? Because see, we can't really cover here OSI model, right? I can't cover, right? I can't teach you that how traffic is going through, right? I mean, how traffic is passing through the routers, then switches, then firewalls, how encapsulation, decapsulation is happening, how TCP connection is coming up. So please go through that by your own. I can answer all your questions. That's fine. I can answer your questions, but after all, you will have to go through that by your own. You read about that. Wherever you get stuck or you get questions, please come back to me. I will not hesitate to answer your questions, right? I can help you with that for sure. But I'm not going to cover those topics. Because see, you have been enrolled here for F5 LTM and F5 GTM training, right? So I'll directly start with the F5 LTM and GTM training. Okay. The next thing is that you should be knowing that from where you can download the images and all that kind of stuff, right? So you do one thing. There is a free trial kind of thing, right, that you get on their website. So when you log into f5.com, you get this option there, right? So let's say you said just f5.com. So there is a free trial. You go there, right? And then just look for the Big IP virtual edition, right? Big IP virtual edition. You go there, and then there is a login or register. So say login or register. So if you have if you never registered yourself, then get yourself registered. And if you already registered yourself, then just get logged in. Oh, come on. Back to login. Just a moment. They will send me some sort of OTP. Give it a sec. Send code. Now they have mandated the verification code, right? So you will not be allowed to log in onto your account unless you authenticate yourself, right? So it's kind of two-factor authentication that they have enabled, right? Using your email. Same now Meraki has done, right? So Meraki has also deployed the two-factor authentication. That's the default one. So now you would see that like many vendors are moving over to email-based two-factor authentication. Although they can also configure some other two-factor based authentication as well, but that's that. All right. So now you can look at here, right? my.f5.com, right? You just log in there. Either you create your account or if you already had an account, then you just log in there. It's like a smart account, right? Like in Cisco, we call it a smart account. From like by the help of a smart account, you can look at your licenses. Also, you can download from software downloads from Cisco, right? In similar way, this myf5.com would give you all the options. So now you could look at here that you have got subscriptions. So you can see that what all things you have subscribed, the trials, the open cases. So you would have visibility to open cases as well. And you have got downloads, right? So if you want to go to download something, then you go to downloads. And then from downloads, you can download different images or whatever you want, right? So I'll show you all the options for downloading things, right? So say I have read, okay, say next. So let's say you wanted to select your product family as Big IP, right? Big IP. That's what I wanted to use here, right? And then product line is like Big IP version 6, 13, 14. So we will be having our training over version 14 because this is what they are using even in their exams. And the most recent version that they have is version 17, right? So it's up to you what version you want to use, right? So ideally, I mean, I'm using version 14 in my lab, right? So, but you can download whatever you want, right? So let's say you wanted to download the version 17 from here, right? So select version 17 family, right? And then the product would be like maybe 17.1.1, right? So that's the most recent one. And then from here, you can see that you can have different images. So for example, you wanted to download it for the virtual edition. So you can select virtual edition. And when you select the virtual edition at top here, right? This is the virtual edition because this is what I will be using in my lab. So I'm going to use virtual edition in my lab. And since I'm using the virtual edition in my lab, then you have to download any of these files. Like for virtual edition for VMware, we have got this OVA file, so you can download that, right? And also you have got QCOW file for KVM. So if you are using KVM, right, as a hypervisor, then you can use QCOW file, right? And apart from that, if you are using, like, let's say F5 tenant, F5 OS, right? So select F5 OS from your product container, right? So if you are looking to deploy it on F5 OS, which is like R series of appliances, right? So for R series of appliances, you will have to use this, tenant F5 OS, right? So when you select this tenant F5 OS, right? So this is release and hot fixes, right? So just select this one, not hot. I don't want hot fix. So just select F5 tenant and F5 OS image, right? So select that, and then you would see the bundle images there, right? So you can download those bundles, right? The QCOW, right? And then you can deploy it on our series of devices, right? So from here you will be downloading all your software. So for different hardwares or for different platforms, you will be downloading it right from there, right? And one more thing that you should be knowing, that for upgradation, in most cases you will be using the ISO file, right? So for an example, if you are looking for the virtual edition, let's say you selected the virtual edition, so you should see the ISO image as well somewhere, right? The ISO image should also be there. If not, then we might have to change the product family then. I don't see that ISO file. But remember, for upgradation, you'd be using ISO file. Ruben, I think you're not muted. I'm getting like your background noises of your message delivery and
Yeah,
that
sorry.
stuff. No worries. Um, Come on. Yeah, just select 17.1.1, right? And then that's where you would get ISO image. Look at this, right? So just select 17.1.1. Do not select like virtual edition or maybe just FIOS. Don't select that. Just select a 17.1.1, and then that's where you would get this ISO image. So remember that for upgrades, we use the ISO images. We use what? ISO images. Make sense? Any of the questions for now?
Sir,
Okay.
can you again show the topics which you're going to cover?
Yeah, these are the topics: the installation, load balancing methods, the health monitor, profiles, right? And NAT, SNAT, iRule, high availability, right? IAPS. So these are the topics, and
So, sir,
obviously big IP administration. Yes.
you'll give some background about, I mean, TCP/IP modules and everything, or like services L4 to L7. Uh, any background on that, or you'll start directly from the?
That's what I have asked you. So I believe that I said it, right? Please
Right.
read TCP/IP model, right? TCP
Okay.
functionality, please read it by your own and then get me the questions, right?
Okay. Okay.
Please read that how this SSL connection is coming up. Like, let me show you. This fi.com
Mm-hmm.
is a secure page, right? Read about it. This certificate is valid. So there is a secure connection that got established between my laptop, right, and
Mm-hmm.
the F5 websites, this web server, right? And probably they are also using the load balancer, right, at their end. But my point is that read about that and then come back to me. Although I will be discussing
Okay.
about the HTTP functionality, that how HTTP is functioning, how
Mm-hmm.
SSL is functioning, I'll be discussing that. But still, I want you to go through it by your own, especially the theory of those topics.
Okay.
But don't worry,
You
don't be
have
worried.
any documentation or any link we can refer to?
You can look at your dashboard. I believe that all of the documents should be uploaded there, especially 101. If
Okay.
101 guide is
Yeah.
there, right, on your dashboard, please go through that. That would have the TCP function, the HTTP functionality, FTP functionality, you know. Eh, eh, and how about like FTP? Like in FTP, do you remember that how FTP works? Like it uses two different port numbers and all that kind of
21
stuff.
and
Yeah. So
yeah,
are you aware
21
that
and
how does that
22.
work?
Yeah.
Okay, yeah, that because that would be important, right? Because if you don't understand the functionality of the protocol, then it is difficult for you to get it deployed on F5. I mean, you can deploy that, but then you don't know that how it is going to behave, right? And in case if
Correct.
that fails, then you would not be able to perform troubleshooting, right? So better that you understand that how things are, how protocol is behaving, right? What is the function of like how protocol functions, right? Any more questions, concerns for now?
Yeah, fine,
No?
sir.
Okay. So what I will be doing, like from tomorrow, I will start directly the deployment of the big IP, right? I'll show you that how it is happening, how to deploy the big IP, right? On the ESXi server, the virtual edition, and then obviously we're gonna start with our lab, right? So I will start directly setting up the big IP first. I will take the GUI access and console access of the big IP, and then we will cover some basic setup of big IP first. So remember that we are going to cover 201 first. So when I say 201, which means that we are going to talk about the big IP administration, right? So that will be the first topic that we are going to cover, big IP administration. So um, under big IP administration, we are going to see that how we are going to set up the big IPs in high availability mode, in HA mode, right? And then how we are going to set up like how to take backup and then how to restore it if needed, and then how to upgrade big IP, how to downgrade the big IP if needed, right? So like all those kind of things we will cover at first stage, and then we will further go for the LTM based training. Muskan, got any questions?
सर अभी बहुत टफ लग रहा है.
उतना नहीं है, लाइक इट्स इजी, बट पॉइंट इज दैट बेसिक्स को अपना रखना आप स्ट्रॉन्ग थोड़ा, लाइक फोकस ऑन बेसिक्स एक बार ना. लाइक आई विल आल्सो शो यू दैट हाउ टू परफॉर्म ट्रबल शूटिंग ऑन बिग आईपी टेकिंग वायर शार्क and using wire shark. So we will be capturing data using wire shark, and then we will try to analyze that how things are happening, right? हम वो उस लेवल पे करने वाले हैं. Things will be easier for you from a big IP perspective, but you have to get yourself ready at least from the like traffic flow perspective, like how TCP connection is coming up, how three-way handshake takes place, why reset comes up, and what is retransmission in TCP, right? So I mean basically उस पे focus रखो और ज्यादा आपको टेंशन लेने की जरूरत नहीं है. Don't take tensions because obviously we are going to make it uh, you know more easier as much as possible, right? तो देखेंगे ट्रेनिंग को, ट्रेनिंग आसान रहेगी. LTM is not that difficult product. It is difficult when it comes to troubleshooting. So
Okay.
if things are working fine, if application deployed successfully by yourself, if everything is working, it is good. But When it comes to troubleshooting, then yes, then there are some difficulties. But I would, give you some, like kind of like the SOPs that we follow in production environment, right? So
Mhm.
we have got some procedures that we follow, right, while we deploy the application. So I'll be discussing about all those sort of things with you. So things really becomes easier for you, right? Because obviously we have got some SOPs when we deploy the applications on F5 load balancer. It's not like, okay, you do whatever you want. No, you don't do that, right? So you always take inputs from the application owner, because that application owner who developed that application, right, knows it very well, that how it is going to behave, what all things are required for that application to work perfectly, right? So that's what we will be discussing. So don't worry, I'm gonna cover each and everything from a big IP perspective as well as from the LTM perspective, and of course we will be covering the troubleshooting separately. Okay.
Okay, sir. So for the for the next class, we have to be ready for SSL and
I mean,
TCP
please go through that in meantime, right?
and
Meantime,
FTP.
please go through that. Yeah, I mean, just read about the TCP three-way handshake,
Mm-hmm.
reasons behind retransmissions, reasons behind resetting the connection, right?
Okay.
And also read about the SSL connection. And if you get some more time, then read about the FTP, that how FTP works, right? And
Okay.
then HTTP, I'll be discussing that with you, that how HTTP works, right? Because HTTP is one thing that is really important for you, right? That I'll be discussing. So,
Okay,
like
sir.
for HTTP, you can always discuss things, or you can always look around by going to, like, if you are using Google Chrome, and then you go to Edit button. Over there, you always get an option called More Tools, and then you go to Developer Tool, right? And then just refresh your page, or maybe I'll do one thing under Network. Yes, you go to Network and then refresh your page, and then you can see third-party requests. So these all are the third-party requests that that were made for accessing this page, right? And then also you can look for the blocked request if anything was blocked, right? So you can get what is blocking, right? So sometimes website do not work. So in most cases you are doing troubleshooting on the client PC itself, right? So you should be knowing that as well. Now, if you can get something on it, that would be easy. I mean, that would be better for you. Right now, I know that this is going to be a little difficult, because this is probably new for you, or for maybe people on this call, that how we take the debugs on the browser itself. Because sometimes you don't see things in Wireshark, because you are using end-to-end encryption, right? So your payload is encrypted, your data is encrypted, while you are trying to capture the data, right, somewhere in the transit, right? So in Wireshark you don't get everything there, right? But then over here you see everything, in your browser, that what all sort of requests were made, right? Which got failed, which got completed successfully. So you get everything there, right? So now for an example, now if you look at the blocked request, so if something was blocked, then it would have displayed me third-party requests and blocked response cookies, right? So that is also something that it would display you. So you can look at here, right? And then apart from that, you could also look for, let's say, if you open up any one of these messages, right? Any one of those, right? So for an example, F5 logo, SVG, or something like that, right? So just look at there. So if you select any one of them, then also you can look at the payload, right? So this is the payload that you got, and this is the header. So this is the request header. First you should get the request header, and then you should have the response header. This is the request header that we sent over, right? And this is the response header that we got. This is the response header, and this is the response code that we got, 200 OK, the remote address, right? Okay, and the request URL. This is what we sent, and then response, this is the response you got, right? The payload, the timing. So also you can look at the timing, that how quickly this response came back, right? For how long you needed to wait. So I mean, there are so many things, right? And now if you want to make yourself perfect in that, then yes, it's not like you don't really have to worry about that. I mean, It's not like you can escape this thing. You can't escape this if you want to really become expert into this kind of stuff, like especially troubleshooting. Because at the time of troubleshooting, all these things works really, it really helps for you, right? So you just log into client browser and see what's happening there, right? And then you come back to your load balancer and see what's happening there. Even on load balancer, you can take the captures. You can capture data using TCP dump and then analyze your data, right? So there are many things that you could perform, and that's what we're gonna learn going forward. So it's not. I mean, it seems to be difficult, but it is not that difficult, right? The performance, right? If you are just monitoring the performance here, right? Memory, application, and so, right? This is the performance. So for loading, scripting, rendering, painting. So this is how much time it took actually. This is in milliseconds, right?
सर
So
ये HTTP के अंडर आता है क्या?
हाँ जी.
ओके.
और ये ब्राउजर दिखाता है, ब्राउजर विल डिस्प्ले यू. सो ये HTTP, बिकॉज ब्राउजर में जो भी आप कर रहे हैं एक्सेस, दैट you are accessing through the HTTP, right? Basically, you are using HTTPS, correct?
Yes.
So if you look at there, so you must have sent, like if you look at the header, you must have sent the get request, right? तो यहाँ पे देखिए response header and request header.
Okay.
Oh, come on. मैं आपको रिक्वेस्ट हेडर दिखाना चाह रहा हूँ. यहाँ पे रिक्वेस्ट हेडर पोस्ट यूज किया आपने यहाँ पे, राइट? तो समटाइम्स यू विल बी यूजिंग पोस्ट, समटाइम्स यू विल बी यूजिंग गेट, sometimes you would be using maybe delete, put, right? So there are methods that you use in HTTP. तो वो मैं आपको बताऊंगा कि कौन कौन से मेथड्स होते हैं, राइट? एंड व्हाट आर द यूजेस ऑफ दोस मेथड्स, सो एंड सो. तो वो मैं आपको बताने वाला हूँ. यू डोंट रियली हैव टू वरी अबाउट दैट.
Okay.
And then when you get the response, then you get the response code. Like 200 OK is always good to see, right? 200 OK is always good to see. If you are getting something else, sometimes like you might get the redirection as well, the status code for redirection. So that is also good. But if you are getting something else, then yeah, it can be difficult. Then there is a problem then, right? तो यहाँ आप सब कुछ देख सकते हो. अपना जो भी वेबसाइट आप लोड कर रहे हैं ना, जैसे आप यहाँ पे जरूरी नहीं F5 पे ही जाएं आप, राइट? आप cisco.com पे भी जा सकते थे. यहाँ पे cisco.com, राइट? तो अभी नाउ यू एक्सेस द cisco.com, राइट? तो cisco.com को भी आप यहाँ पे आपने इसको रीड किया और यहाँ देख सकते हो. अगर कोई ब्लॉक हुई है रिक्वेस्ट तो वो यहाँ दिखाई देगा, राइट? एंड इनफैक्ट इफ आई गो अप cisco.com, look at the headers. So this is the request header that I sent, right? The get, and then it said that okay, it was moved permanently to this location, right? So they redirected first, right? And then thereafter, if you look at the very next, so then this is where you hit now, and this time you got the 200 OK, right? And if you look at the response here, right? So this is the response you got for this request. Look at this. But you don't really have to read it, because this is something then that application owner would read, right? Because that's not my job. My job is to look at the header and the response code is 200 OK. That's it. That's all we needed, right? So you can read all this information over here, right? I mean, this is about the HTTP headers. Also, you could look for the initiator. You could also look for the timings, how much time it took to get this transaction completed. And then you can keep on looking for the information, right? So that's what happening. I'm telling you, most of the troubleshooting can be performed on your PC itself. You don't really have to go to your F5 load balancer. So if you are logged in onto the client PC and if you are really aware that what's happening or what you should check, then you can perform troubleshooting. Most of the time, you can perform troubleshooting on your PC, your laptop. Right. Any other question?
Saurabh, can you please show me the topology?
Mm-hmm.
Uh, just for a second.
Mm-hmm.
I have a question here. As a network security engineer or the
Mm-hmm.
F5 administrator, do we need to worry or know about the background how things are working behind the server? For example, let's say so the request normally will come from the ISP to our internet gateway, the firewall or router facing the internet, and the request will be forwarded to the F5.
Mm-hmm.
Correct. Normally in generally for a small kind of companies, so they won't be having the F5 setup, so they'll be having basic the firewall. Behind that they will have the single servers where the https request, web server request will be coming, and firewall will be forwarding to it, and the response will go back to the client who is trying to access the particular website. But this F5 will be implemented like a bigger infrastructure, like enterprise level, where like the our Indian Railways or any flight websites. Emirates like a big company, Air India like a very big enterprise company, where millions of or under thousands of lakhs of internet requests to be coming at the same time in a seconds or a minute. So in that case only the big IP will be useful, right?
Yes, absolutely.
So in this case, for example, in our concept, let's say we are using I-MEDITA.com. So for this, you are having this 6 servers behind the F5. So when the request coming to big IP product, so it will forward the one request to the server 1 and 2 3 4, and or it will be sending to all server at the same time. And how the things are working behind the server. For example, let's say it is like a Indian Railway website where the bookings are happening every seconds. So if one user one from outside is trying to book one ticket for the ticket for the seat number A, there are seat number, let's say seat number A B C D, like 1 2 3 4 5 6. So if a user from outside trying to book a seat for a seat A, then the big IP will be forwarding each and every request from user one. It will be forwarding to seat A, or how is it? Because those servers has to maintain a central database, right? Like it could be a SQL, or how is it? Do we need, as a network administrator, do we need to understand those concept also, or we don't need to worry about that? We need to look only in our big IP and forwarding the request to the servers. That is our job.
That's your
Or
job. That's only your job. You don't really have to worry about that how database is working.
so if
Your
anything
job,
happens for
your job is to take data from client to server and from server to client. Because what
okay,
server is responding, that is not in your hands. If your F5 is modifying something, then there is a problem, right? But
okay,
there can be some specific requirement for the backend server. Like if backend server want your application server want that once client is connected to one of the application server during booking, then it should not go to any other application server. So you have to enable the persistence for that. You get one point?
okay.
So, I
So
mean, that then you can have like different requirements for different application from the application owners, and accordingly, you should set things up in your big IP.
mm-hmm.
But they would come to you that what they want, or you would ask the questions for the application owner. What do you want? How you want me to set up this application, right?
Okay,
So you can create one questionnaire, and then you can simply ask those questions to that application owner. That this is what I use to perform when, like I'm working with one of the client. So I'm also having that questionnaire, complete questionnaire. I'm putting all the questions in front of him. Now tell me, or I'll just set up based on the best, uh,
yeah, recommended method or
yeah, based on
kind.
like the recommended settings, right?
Okay. So there is a dependency on the system side, system
Obviously,
engineers or a system
obviously,
administrator.
not
So in
administrator. I would call them application owner.
application owners.
Yeah,
So for
you
example,
have dependency on application team.
okay, so if there is any server is down, completely down, or in due to order failure or power failure, if any server is coming, server is failed, the big IP will be still forwarding the request to the set server. So that request will be dropped. So So as a team, we should be knowing that if anything happens to the upgrade from their end also, we should be knowing so that we can turn off that
You
particular.
have the monitoring. You have monitoring enabled on F5. That's what you will be covering. There is a topic called monitoring. So you keep
Oh,
monitoring those services running on F5 or on backend servers. So if service goes down on any one of the backend server, then obviously your F5 will stop forwarding request onto that server. Simple as that.
okay. Thank you. Thank you. One more thing. Who is the competitor for this? Parallelly for
There are
equally
many.
there are.
There's Citrix, Natiscaler, there is A10, right? Um, then Camp is there. I've seen people using Camp, right? But F5 is on top. I mean, nobody
Hmm.
is near to F5. Even nobody is near. So it's
Okay.
like when you
Like
ask
Palo.
someone that, okay, what is this? What is the difference between Cisco and Juniper? I don't think. I mean, I don't consider Palo any like anywhere near to Cisco.
Yeah, that's what. And if in security wise, Palo Alto is number one. So same like that for
See,
the load
uh,
balancer.
but there are many others which are nearing, uh, the Palo Alto, right? Palo Alto is
Okay.
a top, I got it. But there are many other vendors which are very much near to, such as FortiGate is there.
Yeah.
Then there is I mean, Cisco is also there. I mean, I don't see why people are ignoring nowadays Cisco for its FTD product. FTD is a good product. I worked on it. So, then Checkpoint is also there, right? But FortiGate
Yeah.
is really competing with Palo Alto. So if somebody says that no, Palo Alto is at top, but then I would say no, FortiGate is also equally, like is somewhere near to Palo Alto, right?
Yeah.
So point is that in F5, like when it comes to load balancer, then there is a huge gap between F5 and Citrix Natiscaler, right? There is a huge gap.
Hmm.
It's not even near to F5. So I would say like in routing, switching, wireless, overall, altogether, when it comes to the network equipment, Cisco is like 60-70% of the entire market is captured by Cisco, right? Overall.
Yeah.
And in similar way, the F5 has captured 60-70% of the market, and all other vendors are in remaining 20-30%.
Okay. Okay. Good. Thank you. Thank you.
But Cisco is trying to nail down the F5 because Cisco had a load balancer, Cisco ACE. They
Hmm.
had that load balancer, and that was eliminated, or that product was completely blown away by F5. And since then, like Cisco has been thinking that how to counter F5, and they started investing in A10. So Cisco has invested a lot of money in A10, and they are trying to they are trying to I would say uh, they are trying A10 to compete with F5 actually, right? And they are trying that A10 should create products which could compete with F5. But I mean, as of today, when I'm speaking to you, A10 is nowhere as compared to F5. But yes, when it comes to cost, A10 is very cost effective as compared to F5 because F5 devices are very, very costly. Those are very much costlier, right?
Yeah, you cannot compete for all the product because Cisco is having all the network security, all the products. So if you go to security itself, Palo Alto is being number one. You cannot compete Cisco with the Palo Alto because Cisco is doing all the product, whereas Palo Alto
Yes,
focuses only
yes,
on
yes,
security
yes,
product.
yes, absolutely. And that's what kind of advantage Cisco gets in most
Yeah.
cases. Like when people sees, okay, they have got Cisco router switches, then okay, let's use Cisco firewall because I don't want to use now any other vendor. Why? Because I don't want to take headache. I'll have just one account manager and all that,
Yeah. Yeah.
right? So sometimes people, like I have seen in United States, they mostly trust Cisco FTDs in
Yeah.
US, especially in government projects, in their federal government projects, right? In federal projects, I have seen that they are preferring Cisco FTDs, not even Palo Alto. And now I don't know what's the reason behind that, but I've seen that. All
Yeah.
right.
Thank you.
So yeah, see you in next week then. And by
So
then,
one question: are we going to cover the deployment methods also? How to
yes,
deploy this
absolutely.
F5 one
Yes,
or
yes,
single,
yes, 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 absolutely. Why
okay.
not? Hmm.
And route partitions, how to create route partitions, that
Yes,
also.
yes, yes, yes.
Okay.
Mm. It's just partition, not route partition, right?
Oh, partition.
Yeah,
Yeah.
it's just
Okay.
partition. Yeah,
Okay.
absolutely.
So
Yeah.
class will be on Saturday, right? Next to Saturday.
Yes, yes, yes. Hmm.
Yeah, thank you, sir.
During our previous session, we had a discussion that which all topics we are going to cover, right? And then we also, I also requested each one of you, whoever was available during that session, that you should go through the TCP correction, the workings of HTTP, workings of Telnet, FTP, right? So, in nutshell, I would say that I did ask you to go through the TCP/IP model or OSI model. Apart from that, we also had a discussion around the different I would say products within F5. Like we spoke about the different modules offered by F5. Like here during training, we will be covering LTM, Local Traffic Manager, and DNS, which is Domain Name Server. These are the two modules that we will be covering during this training. But as I told you, we will be covering these two modules only. But during previous session, I discussed like which all different modules are offered by F5. We also spoke about their certifications, and also I spoke about the Big IP platform, right? We just covered the basics of Big IP platform. Like we have got cloud edition, we have got virtual edition, then we have got the appliances, then we have got chassis. So which all chassis were available, which all appliances were available. So we had a discussion around that. So probably each one of you got a good idea about the big IPs. But today we're gonna get started with the deployment of the big IP. And the deployment of the big IP, since we do not have, like here in our labs, we do not have the hardware big IP. Instead, we have got the virtual big IPs. So first, I will let you know that how to deploy the big IP on top of the ESXi server. So all you have to do is, like for an example, if you go to f5.com, right? So let me log in quickly here, right? Just give me a moment.
Hi, Saurabh.
Yes, Ankush, tell me.
Yeah, hi. Actually, I just joined this new course. So I went through your, last session
Previous
and
session, yes.
yeah, previous session, and I'm very new to F5 because my total work is on data center routing, switching, and firewall. So
Mm-hmm.
I never worked on it. So can you just like give a little brief, in a kind of layman language, what exactly the F5 do, that will be really helpful.
Mm-hmm.
Yeah,
Sure.
yeah, thank you. Thanks.
So I was able to log in onto F5 accounts.f5.com, like which is my.f5.com. That's where you get logged in. In fact, I spoke about that how you can create your trial account on f5.com, right? So if you go to f5.com, there is an option to create an account for trial licenses as well. So there is a free trial. You go there and then select Big IP Virtual Edition and Big IQ Centralized Management VE. So you click there, and then it would give you like get your 30-day free trial started, and then you could simply say login or register. So once you click there, it will give you a page from where you can get registered yourself. So like you can create your F5 account, provide your legitimate email address because you get the OTP, because now F5 has mandated the multi-factor authentication MFA using your email address. So not only you will have to put on your password, but also you will have to put on the code, and F5 will send you the code over your email address. Okay. So put your legitimate email address while creating your F5 account. Okay. All right. So that's that. And then as you spoke about like the uses of F5 load balancers or whatever, right? This F5 technology. Okay. So let me give you the brief idea. Although I had a discussion during that topic as well during our previous session, if you went through that recording completely. But yeah, let me just explain it to you now. So point is that when it comes to the F5 is also vendor similar to like Cisco or others, right? They are vendor. They are manufacturing sort of devices, which is called big IP, right? So there is a F5, it is a vendor, right? Ankush, are you
Yeah,
with
yeah,
me
I
now?
can.
Hmm.
Yes, yes, yes. I'm able
Okay.
to see.
So F5 is there, right? F5 is a vendor, right? And who is manufacturing like big IPs? Who does manufacturing of big IPs? Big IP is a product that they offer, right? I mean, it is a device actually, I would say, in nutshell, and they use the operating system called TMOS. Now they use this big IP for multiple purposes. Like this device can be used to perform load balancing. So when I say load balancing, which means I'm talking about the LTM module, right? This box can itself be utilized for a DNS, which means you can use it as a DNS server. This module, or sorry, this big IP, this device can also be utilized as the WAF. Also, you can call it advanced WAF because now F5 calls it advanced WAF, web application firewall. Now, this box can also be utilized as AFM, right? Which is advanced firewall module, right? So it can also be utilized as a firewall if you want to use it, right? You can also use it as an APM, access, policy manager, right? So it's like kind of for remote access. If you want to grant the remote access for your applications to your end users, then you can use this APM module, right? And then you also have got the SSL orchestrator, right? So you can also utilize your big IP as your SSL orchestrator. And there are a couple of more modules that that F5 offers, right? Point is that you can utilize your big IP for the purpose of load balancing. That's the primary objective of this F5 uh, technology, right? So if you look at here, F5 is offering you multiple technologies and load balancers, LTM and DNS. Those are the two most popular technologies that people use from F5, the LTM one and the DNS one. Obviously, people also use advanced WAF, but AFM and APM, you will not see those two modules very much popular, right? But when it comes to the popularity of the technology offered by F5, that is your LTM and DNS. So LTM stands for Local Traffic Manager, right? What it does in nutshell, like I'm just trying to explain you in layman language, right? So what it does, for example, you know, let me bring up. Okay, leave it. I will just draw the diagram. So what happens is that you always access your web applications through the internet, right? Like you are accessing facebook.com, you are accessing cisco.com, you are accessing youtube.com from home, right? Now, if you take an example of, let's say, let's take an example of, what to say, our GST website or income tax website or IRCTC website where you book your tickets, or maybe any banking site. So let's take an example of any banking site, right? So if you talk about the banking site, which means that you can take an example of STFC, right? STFC.com or something like that, right? So let's take an example of that. So that application or that website must be hosted on some sort of servers, right? There will be some servers, right? These are servers, also known as web servers, where you will be hosting your website, the front end, and obviously in backend, it all this application will be integrated with the SQL Server or wherever. That's not our job, right? But point is that web application must be hosted on servers. Now, ideally, you would see that if you are connected to internet, then you would have a perimeter firewall, right? Maybe then core devices, and from core, then you would go to DMZ, and then you might install another DMZ firewall, and then you will be connected to a switch, and then switch will be connected to further to your real web servers, right? This is the ideal connectivity that you will find in most cases, right? And we as an internet user, we are sitting at home, right? Let's say, and we are trying to access htfc.com. So our traffic will go to data center, right? Now, if you have got just one server, right, in DC, obviously, then it can be a problem related to single point of failure. If you have two of them, then on DNS server you can provide like if you can make the entries on DNS server saying that if somebody is asking for an IP address for www.htfc.com, we should provide an IP address of both web servers, right? Now, if one of them is down, right, or maybe both of them are down, there is no way for the DNS servers to monitor if the backend servers are up or down, right? And therefore, and the user will keep sending data to your primary DC. Maybe you had some secondary DC, but and the user will keep on sending data to primary data center because DNS was never aware if the services are down or those services are still are running successfully on the backend servers, right? So that's that. So now the problem was like because we were not able to identify if the services are running on servers, we were not able to basically monitor things, right? And also like if one server goes down or maybe both of them goes down, then I mean there was no load balancer properly, right? If you look at here, there is no load balancer. There is no device who is monitoring the services offered by these servers. So that's where we placed the load balancer, or also known as LTM, local traffic manager. So right after DMZ firewall and before this switch and before the servers in between, you can install this LTM, local traffic manager. So you would be hitting to LTM, and then LTM will see that, okay, I have got two servers. No, I mean, then you can also have like two, three more servers. I mean, as per your requirement. But let's assume that you had only two servers. LTM will keep the monitoring, will keep monitoring that if web services are successfully running on the server, right? And apart from that, it can also perform load balancing based on like per TCP connection, like uh, there are many load balancing algorithms supported by the LTM, right? So not only LTM is doing load balancing, but also at same time it is monitoring if the applications are running successfully on servers. If applications are not running on the backend server, which means that now LTM will automatically stop forwarding traffic onto that server, right? And that's what LTM does automatically. So that's local traffic manager. Whenever it receives the traffic coming in from the internet, let's say now it doesn't mean that these applications will not be accessible for the internal users. Even internal users can come and have access to these applications. But what I'm trying to say is that in most cases, load balancers will be needed for a huge amount of users, right? Where your application is accessed by you know a large number of users. And when I say large number of users, which means ideally you would have internet users. So if you are providing the access of your application over an internet, then it becomes really important for us to have the load balancers installed. So that way, the load balancers can keep monitoring the availability of the application on all of the servers, and at same time it will keep on doing load balancing. So just in case if server stops responding, if let's say application went down on one of the server, then this LTM which you installed in DMZ will stop forwarding traffic, user traffic onto that server automatically, right? So that's what LTM is doing. And there are many other features as well. It does not only perform load balancing, but also, as I said, it does monitoring. It's if needed, then NAT can be configured here. Then apart from that, you can also configure the SSL offloading, right? So you can also modify the TCP behavior, in case if needed. So you can play around the SSL, you can play around the TCP. So these all are the things that are supported on LTM. So in nutshell, in short, LTM is doing load balancing among the servers, right? Like even before, it's not that F5 LTM was the first device that started performing this kind of load balancing. We had other load balancers as well. If in fact, if I don't know if anybody knows that on this call, but there was a Cisco ACES, right? That was a Cisco load balancer. It was a module that we used to install on 4500 series of switches or maybe 6500 series of switches, and we were using that module as a load balancer. But that those load balancers had pretty much limited features. But then F5 came in, and F5 wiped out all other vendors in terms of load balancing technologies. Although nowadays, yeah, there are some competitors, right? There are some other vendors as well competing with F5, but still F5 is at top. Like there are some other vendors out there like Citrix, Natiscaler, right? So Citrix Natiscaler load balancer is out there. Then Camp is there, right? Redware is there, right? And there are a couple of more, right? But point is that F5 is still on top when it comes to the load balancer. So the primary technology offered by F5 is to perform the load balancing. Now there are many others, such as I told you, like in F5, the BIG-IP can also act as a DNS server. So now it's not normal DNS. It's not Microsoft DNS server, right? Because I believe that all of you must have heard that we make or we configure Microsoft servers as a DNS servers, right? Or maybe we will use some Linux machine and we'll configure it as a DNS server. But they provide like kind of a basic functionality of the DNS server. But F5 provides you advanced DNS functionality. So it's not just DNS, it is an intelligent DNS, basically, when it comes to the F5. Why? Because even the DNS server would have the capability to monitor if your services are running. If not, and especially if you have got like two different data centers, like DC1 and then DC2. If you have got two data centers and then you have your application hosted, let's say app one, and then that app one is hosted in both the data centers. Now this DNS, right? The F5 DNS, I'm talking about the F5 DNS now. Now for this F5 DNS, you can probably tell that, hey, if someone is coming to you for DNS request for the app one, then for app one, this is your primary DC, and this is secondary DC. So this DNS has capability to keep monitoring if the application is successfully running in DC1. Now, in case if app 1 stops functioning at DC1, then this DNS server, now this is intelligent DNS, I'm talking about the F5 DNS server, it will stop providing the IP address of the DC1 in DNS responses to your end users, to your internet users. Then, like it will simply provide an IP address of the DC2, right? For app one, and thereafter you would see that your users will start accessing this application from DC2, and this switchover or this failover would happen automatically. Now, this functionality is not supported, is not provided by the traditional DNS servers. Like if you start using, or if you are using Microsoft DNS server, you can't do it on Microsoft DNS server. Why? Because there's no way of doing or there's no way of performing monitoring, and that's a problem. Right. Now, I believe that Ankush, you got an idea.
Yes, Saurabh. Yeah, I got an idea. Thank you. Thanks.
Do you have any questions now around this?
No, just one thing, like how this application is being tracked by the load balancer. I mean, is it using TCP or any other?
That we will discuss, because
Okay,
that's the technical thing, right? So obviously we're gonna start and we're gonna cover each and every topic, right, in
okay.
F5 technology. So that's part of the training. Okay. Now, as I told you, even in previous class, previous session, that the objective of next session would be to get the F5 deployed at least on the ESXi server. So I'll go ahead and we'll have the access to the ESXi server, and we'll deploy the F5 BIG-IP there, right? So if you have got ESXi at home, then probably you can follow the same steps. And even if you are deploying the BIG-IP in production environment over the ESXi hypervisor, you can follow the same steps, right? So the first step would be to have access to your ESXi server. So let's assume that we are logging in, like I'm logging in on one of the ESXi server, right? And then we can simply log in there, and then probably we can see that what's going on there. Test V manage. I will shut it down actually.
Saurabh, I have a question. So after registration in F5 site, so we'll be able to download the directly the OVA template file, right, for installing the
Yes, and that's what
F5.
we
So
gonna use
okay,
it.
we'll be getting trial version, like how many days it will be maximum, so we can test on it. Or do we need license? So it will we get the trial version to make it working?
That is mandatory. That is mandatory. Without having the trial license, you would not be able to. I mean, you can deploy the F5, but you would not be able to use it. And that's the thing with BIG-IP. F5
So we
BIG-IP.
can get the trial license from the website itself.
Yes, you can get it, or you can simply email to I-MEDITA. They can also provide you the
Oh, okay.
registration keys. Okay.
Okay. Thanks.
All right. So let me get going, and I will just go ahead and we'll deploy this over file. So first you needed to download it, and in fact, yes, in previous session I covered that how to download that over file. Remember, Muskan, that by going to myf5.com, and then over here we had an option to download. Like you got downloads, and then like once you are logged in here, upon creating your credentials, and thereafter uh, we were here, and then go to downloads, and then select the product from family, right? So this is what we
Yes.
selected, right? BIG-IP, and then product line. So I said, okay, maybe you can rely on 16 or maybe on 17, right? So let's say I said 17, that's the most latest and greatest, right? And then you could select the product version as well. So let's say this is the great latest one, right? And then you could select the virtual edition 17.113 virtual edition. For virtual edition, you would see the over file. So image file set for a VMware ESXi server. So just download that. So select that file, and then it will ask you from which location you want to download. You want to download it from Japan, Singapore, or whatsoever, right? So you go download it. So you could select the download location, and then you can download it on your local machine. So this is the way of downloading the virtual BIG-IP. And then thereafter, you simply go to your ESXi server, and under virtual machines, there is an option to create register VM. Click there, and then say deploy a virtual machine from OVF or OVA file. Select that option and say next. Put the virtual machine name. Now, one more thing that I would highly recommend before you deploy any virtual machine on your ESXi server, you need to design it well with that person who is managing the ESXi server in your organization. If it is you, then it is good. And if you are aware with how ESXi works, then you're good to go. But just in case, if there is a separate team, then you need to work with them closely. All you have to do is, so you need to see that how you're going to deploy the BIG-IP, right? So based on that, you will be creating the VLANs. So when it comes to the VLANs, obviously you would have one management VLAN, so that your BIG-IP can obtain the management IP from the management VLAN. So management interface of the big IP should always part of management VLAN. Okay. Then you have to talk about the external VLAN, and probably the internal VLAN, right? So at least you would be needing these 3 VLANs. But if you are putting your big IPs, if you are installing your big IP in HA, right? In HA, high availability, then you might need one more VLAN there. Now it's not mandatory. You can also use your data VLANs for configuring HA, high availability. The point is that you can also have a separate VLAN for high availability, right? We will also cover that technically, like we will be setting up the big IPs in HA mode, so you don't really have to worry about that. Okay. All right. So you have got management VLAN, you have got external VLAN, you have got internal. Like you need to make sure that you have all those VLANs. Now, sometimes even you would see that having external VLAN and internal VLAN is not mandatory, because that would always depend upon that how you want to deploy your big IP. So you can also make a single arm deployment, right? So there is a deployment called single arm deployment. So when it comes to the single arm deployment, or what all things you have to do is you just have to have one VLAN, just one VLAN, right? So for an example, you had a router, then you are connected to a switch. And in fact, let's say you had Nexus switches. So I'll give you an example of the Nexus switches, okay? So you had a router, and then let's say there were Nexus switches. So you got switch 1 and you got switch 2. They're running VPC. They're running VPC, right? VPC was created between switch 1 and switch 2. Now, probably you had router 1. So then what you can do is, and then probably you had router 2. So router 1 is connected to switch 1, maybe switch 2, and then router 2 is also connected with switch 1 and switch 2. So this is your WAN side, right? Now, your big IP, right? Let's say you had a big IP, especially if you have a physical big IP, because virtual big IP do not support link aggregation, right? So virtual edition is not going to support the link aggregation, but in case of the hardware big IP, you would have one link connected goes to switch 1 and then switch 2, and then you bundle them using VPC, right? Bundle. And let's say for WAN, you decided to use VLAN 10. So all your routers, right? All your routers will be part of VLAN 10, right? And then on big IP, probably you are using the VLAN 10 only, right? On big IP, you are using only VLAN 10. That's the only VLAN. So you would create L3 interface on big IP for VLAN 10. And then probably in VLAN 10 only, you got the servers. Even you would configure VPC for your servers, right? You know that how to make that configuration. I believe that you must have gone through that in data centers. So you would have connections from switch 1 and switch 2 both to your servers, and then you would configure NIC teaming on your servers, and then there would be VPC created on your switches. Now, these servers are also in VLAN 10. But what you will do is that whenever you want to access an application, users will come from external side to your routers, probably any of the router, and then those users or that traffic will be hitting to your big IP using VLAN 10 first. So first it will go to big IP. Now big IP, you will create web, and let's say you are using same VLAN for creating web. And then that big IP will send the traffic over to server in same VLAN, right? In same VLAN. And similarly, traffic will go back to big IP first, and then will come back to routers, and then that way it will go back. Now, this is called single arm deployment. You're using just one L3 connection to connect your external users with your big IP and even to connect your backend servers to your big IP. So this is called single arm deployment. Now, what if I put routers in VLAN 10 and then probably for servers I am using VLAN 20 for servers, right? So let's say I put all my servers in VLAN 20. And you have to create one L3 interface on your big IP for VLAN 20. So you have to configure it as a trunk port then, because bundle is already there between big IP and the switches. The bundle link bundle is already there. So create one more VLAN on big IP and make it L3, configure a layer 3 interface on big IP, because big IP supports you to allocate IPs on your VLANs. So it's kind of SVI, switch virtual interface, right? So that can be created on big IP. Now you would see that you can see that we have got different VLANs, right? And now you cannot really call it single arm deployment now. It's like multi-arm deployment, you would call it, right? Or dual arm deployment. So it depends that how we want to deploy things. So if it is a smaller network, then ideally you would see that external VLAN and then internal VLAN both. For smaller networks, it can be same. But for larger networks, obviously it is going to be different. I mean, the VLANs for external network like this, like for routers and for the connection between routers and the big IP, there will be a different VLAN, and the connection between your big IP and the servers, there would be a different VLAN. But you are playing around the VLANs on your switches, right? The physical connectivity is gonna be same whether you are doing the single arm deployment or probably you are using like multi-arm deployment. So use whatever you want to use. The physical connectivity would remain same. It's just that how many VLANs you are using there. So based on that, so basically this is how we design the network, and this is how you would design the network in production environment if you are working on F5. So if you have got Nexus switches, then in most cases, like I'm 99.99% sure that you would go for the VPC configuration. Now you might also use the VDCs on Nexus, but I will not move into that technology because that is, I mean, there is no relation between providing connectivity to your big IP through your switches and then VDC, right? Because VDC is nothing but I believe that you can learn that by your own, right? I mean, obviously it's not part of the F5 technology or F5 training. But yeah, VPC has to be configured. So now if you are a F5 engineer, so obviously Cisco network engineer must collaborate with you, right? They must be on call with you. They must provide you connectivity, right? They will give you the ports that, okay, these are the ports available on switches. And you will also provide them that, okay, this is the big IP port that I'll be using, so that cabling can be done, right? Because for cabling, it is mandatory for Cisco engineer as well as F5 engineer to provide the details that what port they want to use for making connection between the big IPs and the switches, right? So how this is how things will work for you. Okay. Now, if any one of you having any questions, concerns around this explanation, please go ahead and do not hesitate to ask the questions. So what's the matter here, right? In our case, we do not have this physical big IP. We have got virtual big IP, right? So we have got the ESXi server, which further connects with a physical switch, and that is a trunk port. In most cases, it will be a trunk port. I'm deploying the big IP here, right? So again, it will be a single arm deployment or multi-arm deployment. If it is a single arm deployment, then all you have to do is you need a management VLAN and you need a data VLAN. That's it. If you are deploying the single arm, I mean, if you are doing single arm deployment, right? And if you are using like multi-arm deployment, then for data VLANs, you have to have like maybe one external VLAN and the other one is internal VLAN. So you have to decide that how you want to deploy the big IP. right? As a single arm deployment, right? Or maybe multi-arm deployment. So if you want to keep your external connectivity and internal connectivity with your backend servers, if you want to keep it separated, then use different VLANs, right? But if you want that, yeah, I mean, that's okay to have external connectivity and internal connectivity both using same VLAN, then use single VLAN, and you would call it now single arm deployment, right? So that's the concept. I believe that you got an idea now. Questions from anyone?
Yes, sir. Fine. Saurabh, I have a question. What is the normal standard method that we use it for assigning the IP address? For example, you're saying for single single arm deployment, we can keep the single VLAN itself for the where both the web application, web firewall, web server as well as the F5 will be in the same range, same IP address, same VLAN. So that will be not the standard practice, right? Normally,
That's a
the web
single
server
arm
will be in the,
deployment. That's a
yeah,
single arm deployment. If you are using the common IP subnet for the server, for the big IP, right? For providing internal connectivity, external connectivity, you're using same subnet. But yes, that's not a best practice. But sometimes when you don't have any option to increase the number of L3 interfaces, even if you have got a small network, a small infrastructure, then yeah, it is okay.
fine, great, thank
Okay. And how about you, Ankush? Are you comfortable now with this explanation?
Yes, yes, sir. Yeah.
Do you have any insights over ESXi functionality? Because if you don't have any
Yes.
idea about the ESXi, then it would be hard for you to grab this kind of explanation, right?
No, I'm aware of it.
Okay,
Yes,
good.
exactly. Yeah.
And Muskan, how about you? Are you comfortable with this kind of infra where you have got like ESXi server and then switch and then there is a trunking and then create different VLANs for like there is a management VLAN for management connectivity and then probably you can have a single VLAN for data or maybe you can have separate VLANs for external internal connectivity. Are you comfortable with this kind of physical connectivity? Because this is needed, right?
Sir, I never worked with ESXi,
Uh-huh.
and it's been long since I get in touch with technology. So maybe I need a brush up.
Oh, okay. So if you never touched ESXi, then it will be little different. What is ESXi? Let me tell you. It's a server basically provided by Dell, IBM, or HP, whatever, right? It's a uh, it's a metal bear, right? Device
Yes.
provided by Dell, HP, and then on top of that you install the hypervisor. So hypervisor is kind of like an operating system, you can call it, for this metal bear device, right? So it could
Okay.
be from VMware, which is ESXi, obviously, right? Or it could be KVM. KVM is from Red Hat, right? That we
Yep.
use for the virtualization purposes. So we install either ESXi on these servers or we install the KVM. Now, once ESXi is installed, now on top of it, you can install multiple VMs, VM1, VM2, and these VMs can be anything like maybe Windows server, a Windows machine. It can be a firewall, it can be a router, it can be a virtual switch as well. You can create you can keep on creating multiple VMs on a single server.
Okay.
So it's kind of virtualization that we are using here. So in
Okay.
fact, if you look at my ESXi server as of now, so you would see that you would observe that we have got like multiple VMs there, right? VMs are running like
Yes.
you can see that there are so many VMs like Panorama 1, 2, Palo Alto Firewall, AD server, ICE, Identity Service Engine, FMC is there, right? and TP server is there. So you can see that there are many VMs that we are running on top of these ESXi servers. So just imagine that if you were using them independently, then how many machines you would have required so far. So if you
Right.
count, yeah, there are 15 items in this line, right? So we would have required 15 different devices, but now all those 15 devices are running on a single metalware device. So, right?
Okay.
So this is a single server actually, and this ESXi VMware ESXi is installing. So it's HP server having pretty much good capabilities like 512 GB of memory, then 88 CPU virtual CPU core, 44 physical virtual CPU cores, right?
Hmm.
You get that, and then we have also done the networking between this ESXi and the physical switches. So if you look at the physical NIC, how many NICs are connected? Three. So there are three connections between this server and the Cisco switches, and there is a
Okay.
trunking between this server and the Cisco switch. So this is what I was trying to explain here, right?
Okay, so all these virtual machine will be using the same networking interface, the three interfaces you just showed us?
Exactly, because those are the trunk ports, right? So you can
And
create
then,
as many as VLANs you want, isn't? These are. Mhm.
okay, so
Go ahead.
can you use multiple VMs at the same time? Then how will they communicate with the same interfaces?
Yeah, I mean
Or
that's what
you
I'm
just
telling.
want one? Okay.
No, that's what I'm trying to explain you. You will be using different VLANs, right? So if you look at here, like virtual switches, we have created multiple virtual switches, and then there are multiple VLANs. Look at here, VLAN ID 100 or 095, VLAN 10, something like that, right?
Right.
So different VLANs are created. So you would be using like
Right.
different VLANs. Even you can put like multiple VMs in single VLAN. That is also possible because they can obtain IP address from the same IP subnet using DSCP,
Okay.
isn't?
Okay, so these are the trunk links then,
Yeah,
right?
absolutely. There are
Okay.
those are trunk links. So it's like, for example, you had the ESXi server like we have here, right? And this ESXi goes to the switch, and then switch, and there is a trunk between ESXi and the switch, right? So there is a trunk now. Okay, and then you have got a router or maybe layer 3 switch. So if you are using like VLAN 10 here, maybe you are using VLAN 20, VLAN 30. So all you have to do is that for all these VLANs, create a layer 3 interface, right?
Mm-hmm.
That's the one requirement. So layer 3 interface has to be created on this layer 3 switch for all these VLANs, VLAN 10, VLAN 20, and then VLAN 30, right? And then you can put here your VMs. Let's say you created one Windows machine here, right? And you have put that VLAN in, sorry, that Windows machine in VLAN 10, which means that this virtual machine now would obtain an IP address from DSCP, who is providing services for VLAN 10. So it will become the part of VLAN 10. Now it can talk to its gateway, isn't? So this is how
Yes.
the VMs hosted inside ESXi will talk to the external network. Make sense?
Yes. Perfect. Thank you.
Okay. So
Saurabh, just
yes.
one doubt.
Hmm.
Uh, in that last, I mean, you just draw one diagram, right? Can you please pull
Which
out that
diagram?
just now with the three different VLANs?
Okay. Uh-huh.
Yeah. So I just want to know, right? If, for example, if there are two virtual machine, maybe two different server we have hosted on that EXXI,
Hmm.
and if these two servers, that virtual VMs need to talk to each other in different VLAN, so how they will do it? I mean, they just want to talk to each other. We
So of
don't
course,
want.
got it. But first thing is first that there is nothing to do with the F5, right? And second, you have to perform interVLAN routing, right?
Oh,
So
so the traffic will go to router.
exactly.
Oh, okay, yeah, that
So
was my
first
doubt.
traffic from ESXi will go to your its gateway in that VLAN, and then it will come back.
Okay. So it's not like that within the ESXi they will
No,
talk to each.
no,
Okay,
no.
okay.
There can be. Let's say you hosted a router within the ESXi, right? And then that is doing
Oh,
interVLAN
okay.
routing. If
Okay,
that
okay,
router
okay.
is doing inter-VLAN routing, then yes, traffic will go to switch, from switch to
Got it,
ESXi,
got it.
then again ESXi to switch, and switch to ESXi, like that.
Yeah, because my question I raised this because I come across with some scenario in which this multiple servers are being hosted in the data center and they
Mhm.
talk to each other, and then the F5 load balancers are also there, but I never but because I never worked on
So,
F5, so I yeah,
so
so I don't know
Ankush,
how they
I got it.
talk to.
I got your
Yeah,
point. Now, I believe that you must have understood that how traffic will be going from one server
got
to
it,
another server via F5, because
got it.
traffic will go out using that VLAN towards its gateway, and gateway could be your load balancer as well, right?
Got it. Now I got it. Yeah.
Mhm. Okay. So virtual machine, you want to host a virtual big IP here. So just click create VM, register VM, right? And then select like deploy virtual machine from an OVA, OVF or OVA file. Put down the virtual machine name there. So say test, probably VM, right? Or big IP. Let me put it in this way, big IP VM. Now you have to select your OVA file. So click select OVA file. So let me say that I have got desktop, and then I must have a folder. Over file. Just for WebTail, and I don't need that. I need a F5 over file. Uh, uh, uh. Documents. No. Okay, I'll go to downloads. Then there are many files actually. I'll have to search for big IP. Let me search for big IP. Yeah, I got that. So you can see 15 or maybe 16 is also there, right? So let's say I'm using 14, right? So big IP 14 is there, right? And then say open. So that was the over file that I had already downloaded, right? So this is the .over file. Don't use .iso. If you are using .iso, then there is a different method of installing big IP using ISO file on ESXi. But deploying big IP using OVA is most appropriate way or most easiest way. So download OVA from F5 website, from F5 web server, and then go ahead and say, and then deploy here, right? So I had only one data store available on this server. So it says that this data store is available. Then I'll say next. It will say that, hey, agree to the end user license. So I say, I agree. And then you will be taken to the next step then. It might take a moment over here, right? Okay, then say next, right? Hmm. Once you say next, then you would have to do the network mappings. Like if you have got the management VLAN for management access, like I do, right? So I'll have a VM network. That's my management VLAN. Then you have to provide the VLAN for internal connectivity, external, and for HA. Now, what if you just looking to deploy the big IP in a single arm deployment, like with single arm deployment, right? So you can simply allocate the VLANs um, for a you can put only first interface. Now let me tell you one more thing, that management interface is ETH0 interface. Technically the management is ETH0 interface, right? That's ETH0. But then if you talk about the internal external HA, so this is 1.1, this is 1.2, this is 1.3. Even on physical boxes of F5, like if you look at the physical big IP, the nomenclature for interfaces we use in F5 is like 1.1, 1.2, 1.3, or maybe 2.1, 2.2, 2.3. Sometimes you would have like 3.1, 3.2, 3.3, maybe 4.1, 4.2, 4.3, even 3.4, right? And 4.4, 2.4, and then 1.4. So this is how the nomenclature uh, works in F5. This is how we represent the interface. Like in Cisco, you get like gigabit Ethernet 1 by 0 by 1, 1 by 0 by 2. You get that? Like, do you remember that? And here in F5, we just represent the interfaces like 1.1, 1.2, 1.3. So on your virtual big IP, your interface is like your internal interface, the very first this is management, right? Management is ETH0, right? But then internal is going to be 1.1, external is going to 1.2, and this is 1.3. Now you need to put all these interfaces in their respective VLANs. If you don't want to use HA, let's say you are not looking to configure HA, then call a default VLAN where you will not get any connectivity. And even for 1.2, if you are not using that interface, then also call this interface in, call that VLAN which you are not using for any type of connectivity. But internal VLAN, yeah, that should be that VLAN which you want to use for connectivity between servers and the big IP, and between big IP and the routers, right? If you have got different VLANs for internal and external, then you do one thing: create two different VLANs, and for internal, you allocate the internal VLAN, which means that 1.1 will become the member of internal VLAN, and then 1.2 interface will become the member of external interface then. Okay. So
सर
that's, yes, Muskan.
जो F5 का फिजिकल बॉक्स रहता है तो
Uh-huh.
उस पे जो नेमिंग कन्वेंशन रहती है 1.1 1.2
1.1, 1.2, 1.3, 1.4 ऐसे रहेगा, राइट? 2.1, 2.2, 2.3,
ओके
2.4 ऐसे, 3.1, 3.2, 3.3। और यहाँ पे भी ऐसे ही है, अगर आप इसको देखोगे ना, तो ये भी क्या है, 1.1, 1.2, 1.3। ठीक है,
ओके
ऑलराइट। So we have understood this now, right? That we have to provide the network mappings, which means we have to put these interfaces in the respective VLANs. I put this management VLAN, management port in management VLAN, right? This is also known as ETH0 interface on your big IP. Okay. And then deployment type, it will be depending upon that which type of license you purchased from F5, because sometimes you would purchase a license where you are allowed to use 4 CPU cores and 8 GB RAM. If you select 8 CPUs, this is high performance configuration, right? 16 GB RAM. But I'll keep using like 2 CPUs and 4096. So I'll keep using that, and that is more than sufficient to deploy this virtual machine. And do not change anything else, just keep as everything else as default, and this is power on automatically. You can keep this option, then say next. It will give you the summary, and then if you read this information, if you feel that everything is okay, right, then it will also display you the network mappings, that these are mapped to their these all interfaces are mapped to their VLANs. So if that network mapping is good, then go ahead and click finish. If not, then go back and change that mapping or whatever setting you want to change, right? For now, I'll just say finish, and then when you click on finish, then you would see that your OVA will get start deploying on your ESXi server. So the status is 0% for now, but yeah, it will keep, will keep running it. And at one stage, yes, this deployment will get completed, right? So far it is 0%, but yeah, so you can see that 1% has already got completed, and that way it has to get completed like 100%. And once this is deployed 100%, then your device, your big IP will get powered on, but it will take time. Okay, because I'm on VPN, and I'm forwarding traffic onto the ESXi server using VPN only. So definitely it is going to take time, because it was the size of that file which I'm deploying here is 2 GB, right? So just think of it like I am transferring 2 GB amount of data between my PC and the ESXi server over the VPN.
सर वो इसमें प्रोविजनिंग टाइप करके आ रहा था थिन और थिक, वो क्या रहता है?
That's again that's again related to the VMware, right?
Okay.
So you don't really have to worry about that.
And that should be selected thin every time, right?
You keep it default, although it will work with both. You can opt any
Okay.
option. It just one is in one option it simply reserves the amount of bandwidth strictly for this VM only, and with other option it uses the hard disk in shared mode.
Okay.
That's the only option. or that's the only difference between them. So there is nothing to do with the F5. There was, I mean, those options like thin and thick was applicable in regards with the VMware technology. Okay, so 9% has already got completed, right? And I'll be on mute now, and I will pause the recording as well, and we will wait this to get completed, right? But in meantime, what I can do, I can display you your labs as well, because you're not going to have the access of the CSXI server. Our lab, like even I'm not going to work on the CSXI server every day. Our lab is little different, right? So I'll open up that lab now, right? So I'll log in onto EVE. So your lab is also built on using EVE, right? And I'm also having that same lab here. So I'll open up that lab. So the actual lab is like this, right? So this is your F5 lab, where I have designed it in similar way as we have the F5 technology in our data centers. So sorry, you would have access to the same lab, right? The same topology. Point is that this is your DC, right? This is DC. This is DC edge router, which connects with the internet. And then you have got the BIG-IP1, BIG-IP2. That way you can also configure high availability, and you can see interfaces 1.1, 1.2, right? 1.2, 1.3, 1.2, 1.3, and then management port, right? And then you have got the backend servers. So we will be running application services on backend server. So this is the diagram that I'll be using every day or in each class, right? But as I wanted to give you an experience, that how you can deploy the BIG-IP directly on ESXi server, just in case if needed. That's the reason that I have performed all these steps here, right? So you don't have to deploy it in your lab. It's already deployed. You just have to power it on. So when you have access to your labs, you can power on the BIG-IPs, and then you can start working on that. I will also let you know that how to have the GUI access using one of your lab, right? So you can give me your own credentials, and then I can log in onto BIG-IPs. I can log in onto one of your lab and then explain you that how to work with your lab, right? Because that is really important to understand that how you can work on your lab. Okay. So let this get completed, and I'll be on mute now, and I'll be away for 5 minutes, and probably in 5-6 minutes this should get completed. Okay.
Okay, sir.
Yes, sir.
Resume recording. So now we see that it has been deployed successfully, and we are trying to log in first time now, right? So this is first time login onto the BIG-IP using CLI. So default username is root, and password is default DEFAULT, right? And hit enter. And it will ask you to reset your password, and first it will ask for the current password. So again DEFAULT, and then a new password you can put on whatever you want to put on the password, right? But you have to put on a new password. So now put on the new password, and you would see that, and in fact you can read this message. First it says that the password for admin has got changed now. So we changed the password for the root username, right? But also it has changed admin password. So whatever password you have set for the root, the same password has been set for the admin at the same time, right? The same password has been set up for admin. Now, what is admin and why we have here root? So remember that for CLI access, use root user ID password to log in. For GUI access, you have admin user. These are the default users that you get on your BIG-IP. Later, you can add users as many as you want. I'm talking about the admin users, right? So you can add as many as admin user you want to add. But by default, root is there and admin is there. Admin for GUI access, whereas root is there for CLI access. When you log in through the CLI very first time, you change the password for for root. It will ask you, it is mandatory for you to set the password for the root, right? And the same password that you have allocated for your root user, the same password will be applied for admin. So next time when you log in onto your big IP using GUI graphical user interface using admin password, you have to use the same uh, using admin username, right? You have to use the same password as you defined for the root. Well, if you don't log into your big IP through the CLI very first time, let's say you try to access your big IP using GUI very first time. You are trying to access your big IP first time, and then you are trying to access it through GUI. Then by default, username would be obviously admin, but the password will also be admin, ADMIN. So for GUI access, the default username and password would be admin. If you never logged on your big IP using CLI in past. But if you have, like in this case, we logged in onto big IP through the CLI first. And during that process, it did ask, or it asked to change the root password, and we did change, right? We changed the root password here. Okay. But as soon as you changed the root password, the same password has been allocated for admin. So you don't have to change password for admin separately. You changed it for root, but it got applied for both. Okay. All right. Later you can also change the password for admin if you want, but that's a default behavior of big IP. Also, you can see that uh, you are in bash mode. This is called bash mode. When you are in config and then hash is there, this is also known as bash mode. Give me a sec. Yeah, just give me a sec. Okay. Saying that this is called bash mode, right? Here you can see that all the Linux commands will be supported. All Linux commands, like for an example, if you say ls or cat or whatever, right? You want to use all those commands, use them, rm. So all Linux commands will be supported in this mod. Also, you can see that no license terminology is there, right? And if you want to move into TMOS, the traffic management operating system, the TMSH, right? So command type TMSH, and then you would see that you will be inside TMOS now. So here, all TMOS command syntax would work. Whereas, so that means that you have got like two different options to configure your big IP through the CLI. You got two different options. One, you can use Linux command syntax if you are aware of that. I'm not aware of. Like, I don't use Linux. I don't like that. Or you can use the TMOS syntax. For that, you will have to move inside the TMSH, right? So we moved inside TMSH, and in this mode, we can use the command syntax for TMOS. Like for an example, you can use show commands, you can use list command, you can use create command to create something, you can use delete command to delete something, you know. So these all command syntaxes are there, but our primary goal is to ensure that the management interface has got an IP address. By default on big IP, management interface is pre-configured to obtain an IP address from DHCP server. So I'm assuming that this big IP must have obtained an IP address from DHCP, in my lab at least, right? In this lab, right? On this ESXi server. So I'll just say list sys management IP. That is the command to see if the IP address was allocated. And yes, we can see that IP address has been allocated automatically to the management interface of this big IP, which is 30.212, right? So now I'll try to access that IP address. So say HTTPS 192.168.30.212. Now make sure that you always try to access this big IP using HTTPS. Do not forget to specify the HTTPS in, manually, because there is no redirection from HTTP to HTTPS configured for GUI access of the big IP. Now this is GUI access, right? So username is going to be admin now. You can't use root, and the password is same as what we allocated for root, right? Use that password. If you try to use some different password, let's say default one, admin, it will say wrong password, login failed, right? So you have to put the same password as you allocated for root, because that same password was applied for admin as well. But at same time, that password was marked as an expired. So now you put the current password once again and the new password. Okay, now this process ensures that now you have got different password for admin as well, for root and admin. When we logged in first time onto BIG-IP using CLI, then it did ask us, to change the password for root, but at same time, the same password was allocated for admin. But then here, when we used that password, it said that password is expired, and yes, it was marked as expired password, so that we could change it at first login through the GUI, right? So now we have also changed the password for admin. So whatever password you set on for admin, you set on for root, please make a note of those passwords, because you might forget, and then it's very difficult to reset the passwords on BIG-IP. The password recovery is very, very difficult.